Mercury is a strange, hot mess of a planet. This rock is the closest one to the sun, but its surface temperatures can plummet to as low as minus 180 degrees Celsius. It has the strangest sunrises and sunsets in the entire solar system, and one day on this planet lasts about 2 years. But you don't have to survive a whole day down there. We're sending our team member Chase on a mission to spend just 5 seconds on Mercury.
Mercury doesn't sound so bad. I just don't get why it's so cold. It should be flaming hot.
Detecting extreme temperature fluctuations.
Yeah, Mercury is hot and cold at the same time. That's because instead of a proper atmosphere, Mercury has an exosphere. And this exosphere is almost as thin as the vacuum of space. It doesn't contain enough molecules to transfer heat around the planet, and that means surface temperatures go from one extreme to the other. During the day, the surface is blasted by intense sunlight, and that results in severe heat, like 430 degrees Celsius. Then at night, all that heat gets lost in space, and the temperatures drop to minus 180 degrees Celsius.
Well, at least there's no dust storms on Mercury.
Sure, there's no weather and no climate on this planet, but there are plenty of things that can kill you. Extreme heat, intense cold, lack of breathable air, severe solar radiation, and if anything goes wrong with your spacesuit, you'll be toast.
Toast or popsicle, depending on where I land. You know what? I've died way too many times to go out there without prep. Rico, fire up the Simulatoratron.
X-29 Sim on standby.
Simulatoratron. Fine. Run the thing. Find me the safest place to land, please, Rico. Chop chop.
Yeah, finding a perfect landing spot on Mercury won't be easy. Mercury is the smallest planet in the solar system, even smaller than Saturn's moon Titan. And its terrain is just as bumpy as its temperature fluctuations. It has so many craters, cliffs, and ridges that finding a flat surface to land on will be a big if. Then, of course, there's the lack of atmosphere, which makes landing even bumpier. Without air resistance, your spaceship will be approaching the surface at a very high speed. So if you're not interested in crashing, you'll need a spaceship with a powerful propulsion system to slow you down during descent. And Mercury's proximity to the Sun complicates things even more. That's because the Sun's enormous gravity causes this planet to orbit the star on an elliptical path. That means that sometimes Mercury is closer to the Sun and other times it's further away. So landing on Mercury would be like trying to hit a moving target while being pulled strongly by the Sun, all the while trying to manage your speed in a place where you can't just parachute down. Yeah, it's hard. If you managed to drop down onto Mercury during its daytime, it would feel like you landed in an oven. The sun on this side of the planet is so incredibly intense that it will roast you alive. And Mercury's daytime lasts a long time. To be specific, one solar day on this planet goes for 176 Earth days. Weirdly, that's twice as long as 1 year on Mercury, as it only takes 88 Earth days to revolve around the Sun. Of course, there's no way you'd last a full Mercury day. You'd cook within minutes. Now, even NASA's spacewalk suits are designed to withstand temperatures of 120 degrees Celsius. Mercury is 3.5 times more scorching than that. Your spacesuit's outer layers would start degrading within seconds. In minutes, your suit's critical systems like life support and cooling would fail, and you'd experience instant heat stroke. Then you'd be cooked and die.
Oh, so you're saying I could last 5 seconds on there? That's all I needed to hear. Rico, initiate landing sequence.
I don't recommend that. Your chances of returning to the ship after a 5-second walk on Mercury's daytime surface are, calculating, 0.012%.
Rico, oh my god, you just had to ruin all the fun every time. Okay, what are my other options?
Calculating. Try landing on Mercury's night side.
Okay.
Now, the dark side of Mercury would be freezing.
Detecting the temperature of minus 180 degrees Celsius.
Even your spacesuit's most advanced heating system wouldn't last long in this brutal environment. Within minutes, your heaters would fail and hypothermia would set in. Your body temperature would start dropping rapidly. In only 10 minutes, you'd be dead. And that's if nothing else goes wrong.
Yeah, landing on Mercury's night side is possible, but it would suck. Like, I wouldn't see a thing there. What's the point in going to a whole new planet if you can't enjoy the views? No, I'll take my chances with Mercury's extreme heat. Thank you very much.
Well, hold on. Maybe you don't have to. You could find a landing location between the two extremes. It's called the Terminator Zone.
The Terminator Zone!
Yeah, this is the zone between the day and night, and temperatures there might be bearable.
Calculating the Terminator Zone temperatures would be extremely hard. The temperature on Mercury drops to the extremes rapidly.
That's true, but this is your best shot at spending 5 seconds on Mercury. And hey, remember I mentioned the strange sunrises and sunsets on Mercury? Well, here's your chance to see them too. Mercury has a double sunrise. It's because it moves on its axis very slowly but orbits the sun very quickly. At certain points, the orbital speed becomes faster than its rotational speed. And if you were standing on Mercury at that moment, you'd see the sunrise, then stop, move back, and rise again.
Oh, cool! Double sunrise! I'm for real.
Landing complete. The temperature reading at 130 degrees Celsius.
Okay, yeah, feel toasty, but not cooked. Another successful mission for the Astro King and his dumb sidekick Rico. Okay, so when do we land it? Okay, well, I mean, it's not that bad. I could stick around here for a few hours. God, Rico, just say 3 hours. It's fine. I'll be fine, okay? I'll stay right here. Breathe puts it on his Patreon because I subscribed last month at the Red Giant.
Oh, classic Chase. But don't worry, he'll be back for his next adventure. He always comes seconds on Mercury, but I think we can do not 1 better, maybe 8 better. He's going to lead us through the computer systems and spend 24 hours on each planet. Let's get started on the same planet that Chase was just on.
Beautiful Mercury.
Beautiful Mercury. I don't know if you noticed I put the glasses on, and that's something that people in that video with Chase about Mercury, but we can recap a few of them. First of all, a single day on Mercury. 2 different ways to calculate a day. Sunrise to sunset on Mercury is 56 hours.
I see
58 hours. 58 hours.
days.
But an actual full rotation of the planet takes 176 days. One orbit around the sun, a full year, takes 88 days. So lots of days to keep track of.
It's also pretty quick, you know, with 365 for Earth. 88 days. That's
88 days.
That's
So
like 2 and a bit months.
So if I was on Mercury right now, I would be 299 years old, probably, something like that.
Wow, Peter.
I wouldn't be that old, but it would be older than what I am right now, and it's embarrassing. Temperatures on Mercury, they swing from about 430 degrees Celsius, which is 800 degrees Fahrenheit, to about minus 180 degrees Celsius, which is minus 290 degrees Fahrenheit.
That is quite the swing.
Yeah, that's a big swing. And why is that?
It's just because there's no atmosphere. It's like, think of it, what I think of when you talk about that temperature swing is the desert. When we go to look at something like the Sahara Desert or something like that, at nighttime, freezing, and during the day, boiling hot, and you're seeing that with Mercury because
There's nothing to retain that heat.
Nothing to retain that heat, but it's also the closest planet to the sun. So of course, when the sun is really close, it's just making it heat up like crazy.
And the sun is kind of funny on Mercury, isn't it?
Sun's always kind of funny, to be honest.
You get the sun rise, set, rise. Doesn't it stop and seem to go backwards at some point?
That is a great observation, because what we're seeing right here is as we speed up time, that sun's not moving. A little while ago, if we were to back up a bit, you notice that it's starting to rise here, right? And so you expect it to just keep rising, right?
Of course.
But as time kind of goes on, it's just slowing down, and then suddenly
It looks like it's crashing.
it's just stopping in there. And in fact, it kind of seems to be going a different direction. And
It
slowly,
looks like the Artemis.
it's kind of being slingshot around. Even as we're trying to follow it, I can't follow it in that perfect
Stage 2
formation.
rockets ready to fall.
This is where we should go next, other than the moon. We should go to Mercury.
Mercury, a trip to Mercury?
Yeah, why not?
Well,
As you can see, it's like slowing down here. We're gonna get like a little bit of a sunset, but in a little while, it's gonna come back up in a different type of direction. Let's see if we can find it as it slowly takes its time. Keep in mind, it takes a long time to get through this.
right.
So we're gonna speed this up a bit. Oh,
We're really speeding it up.
yeah. Let's
1 billion times.
let's see if we can find that sun. Where are you? There you are. So as we can kind of see that kind of pop through there.
There you go.
And so what you're seeing when the sun kind of like slows down here is that this is what you were talking about in that rise, set, rise, where
Yeah.
in certain parts of Mercury, it's gonna look like you're kind of like this, and then it kind of comes back up, and then it kind of goes down again, and then it goes back up. And it's just, that's
So
just the way that,
When's retrograde?
sorry.
Mercury is in retrograde. What does it mean?
That is something for you and your
Doesn't have to do anything with the sun?
your astrologist, actually. I think that's an astrology thing.
Oh. Oh, okay. I thought it might have had something to do with. No, it's an optical illusion where Mercury appears to move backward in the sky 3 to 4 times a year for about 3 weeks.
But astrologically, this period is associated with communication breakdowns, travel delays, and technological glitches.
Yeah.
So, guys, this is the time to pause, reflect, and avoid signing major contracts. What does that mean?
So we've actually just come out of retrograde, and the next retrograde, June 29th, is when Mercury goes back into retrograde for
the time to
almost
sign-
a month.
This is the time to sign contracts.
Yeah, sign-
Now is the time.
I
June.
mean, yeah, this is, are we just doing horoscopes now? What's happening here?
I'm a Pisces, so.
I'm a Pisces too.
Oh, look at that.
It's the first time the fans have ever heard that. Expect birthday presents. Thank you. The other thing about Mercury is it's got a severe day side and a severe night side, right?
Day and night.
So you're standing on the day side in the sun, and the heat is about 430 degrees Celsius. And you can walk on Mercury. It's got gravity of about 38% of what Earth's has. But as you're walking on it, the heat from this planet is emanating up through your space boots. And pretty soon that 430 degrees is coming through your suit and radiating into you and you're frying. So you want to get away, you run to the cold side,
As we are here.
as we are right there. And pretty soon when you're on the cold side, the exact opposite happens. So you're in minus 180 degrees Celsius weather, and you quickly cool down, and then all of a sudden the cold is radiating up through your boots and freezing you from the bottom up.
This is where we start to see that. Look at this rapid temperature change, even as we just go a tiny bit, a couple kilometers.
Oh,
and-
you're seeing it right there.
Yeah, we're seeing this local
Can you see that
temperature
at home? Can people at home
Yep.
see that? Okay, great.
information. So we can see that 63 Celsius. That's hot.
Yeah.
Hot, hot,
That's-
hot. And so what we're talking about here, I want to go to that cool side, so we start going towards the dark side. Mercury, not Star Wars, and we start to look at this drop already.
Woo.
8 degrees, 7 degrees, and it's starting to decrease even more.
Reminds me of the McDonald's McDLT. The McDonald's lettuce and tomato. You kept the hot side hot and the cool side cool.
What?
The McDLT, look it up, Google it. It came in a styrofoam container with the hot part on one side and the cold part on the other side. And then you would take it, and when you were ready to eat it, you'd open it up and you'd put the hot and cold together. So it wouldn't be like, they're not going to serve you the cold and the hot together and just let those temperatures come together for you. You got to make the decision when the McDLT. Perfect.
I'll put it on screen.
DLT.
Did you have those?
I used to eat McDLTs all the time.
That's crazy. It's
Yeah.
a wonder they haven't been brought back.
It really is. McDonald's pizza. I'm also waiting for McDonald's pizza to come back.
That was a thing?
You don't remember the? Oh my God, am I aging myself? Anybody in the comments, please tell me you remember
Are
the
you like-
McDLT and the McDonald's pizza.
Aren't you like 229 years old?
I'm on planet Mercury. I'm 299 years old.
Which is when...
And planet Mercury still has the McDonald's pizza oven. Now, what am I looking at here, Stu? Is that the actual, it looks like carpet, wall-to-wall carpet on Mercury? What's happening here?
That's rock. Look
Okay,
at that.
that's
rock. Because as we zoom out, we're gonna start to realize that Mercury is just, Mercury is a lot of rock and a lot of craters and a lot of explosions.
There was something I wanted to show about the craters.
Yeah.
There's a place on there called Calorus Basin. Maybe you can take us there. Oh, that's it, right there.
Look at that. You can really see just the size of it. You see the other parts here and here, these giant smashes here, but then you see this one.
Well, you talk about you could see the size. Now, I can't tell the size because everything is relative. So when I look at that, that just looks like a small little pimple on this planet. But actually, it's 1,500 kilometers wide.
Massive. Well, the big thing to realize is like, if we kind of back away a little bit, this can help you. Do you see these white spots here?
Yes, yeah.
And then you see the giant, you can kind of see, it almost looks like an impact. You can see like this stretches out from here. This is the, and then it being shot out here. So yeah, that's that caloric, it's like Calorus Basin right there. And it's absolutely massive. And
Zoom out just a little bit more from here. A little more.
Yeah.
See that brown spot at the bottom? Zoom out.
Yeah, it's a nice brown spot.
Is that Uranus?
Uranus.
Okay, so this is the crater, and what a crater is, it's not necessarily just a hole in the ground or like an impact in the ground. It is, but what happens after this impact, whether it's from an asteroid, comet, whatever has hit it, the ground pushes out.
Yeah.
So what you've got is a ring of mountains around there. That's not just dust. That's not just flat, and then we're going inward. We're going inward, and then the edges have come up and out. So that's a ring of mountains around there. Yeah. And that, like I said, it was, what did I say? It was 1,500 kilometers wide?
Yeah.
Well, the basin in there is 300 kilometers wide.
Oh, we lost it.
I'm sure we're gonna have it again. I don't know what happens with Stu as my faithful space engine operator. He sometimes decides to zoom out, get out too quick.
Sometimes space happens to you, you know?
In the middle of talking about the Calorus Basin, and now he's just back to the menus again.
What kind of thoughts are you feeling? And I'd like you to rank it on a scale of, let's say like 0 to 10.
Okay.
10 being the absolute best you've ever seen, you love it, and 0 being
Are we gonna rank every planet?
awful. We're gonna rank every planet, and we're gonna...
Okay, so I know what's coming up in a couple planets from now.
Yeah.
So that'll be my baseline. This is, from what I know about the solar system, it's, well, obviously it's a rocky planet you can walk on.
Yep.
It gets really, really hot under your space boots. And then really, really cold under your space boots.
Right now, we're looking at around 247 degrees.
That Calorus Basin looked really cool.
It did.
All those basins look pretty cool. It's the lack of atmosphere that sort of throws me. Okay sunset. I like the solar flares coming off. What would I rank it? 5 out of 10.
Good starting point.
Yeah.
I think 5 is perfectly, I think that's great. I think it hits some spots. It's a little warm. It's a little not perfect.
Yeah, it's a little too warm, a little too cold. Maybe we could build some sort of space capsule that would cool us and warm us during the warm and cold points.
Yeah.
And we could survive there. Not likely, but
we'll see.
We'll see. Okay, on to the next one.
Welcome to hell. Yeah, sorry, I meant Venus. Welcome to Venus. Some say it's Earth's twin, but this world is nothing like home. And you're about to experience this scorching hot landscape firsthand. Your mission is to spend 5 seconds on this hellish planet. And trust me, these are going to be a very long 5 seconds. Venus is the second planet from the Sun and our nearest neighbor. At its closest approach, Venus is a mere 40 million kilometers away from us. After just 4 months in space, you'd finally be able to witness this beautiful but deadly planet up close. 4.5 billion years ago, Venus and Earth formed in the same corner of our solar system. This space rock is about the same size as Earth, and its gravity is similar too, but unlike our home, the surface situation on Venus is extreme. We know this because we've sent probes to this scorching world. Some probes orbited it, some made a flyby, and some even landed on the surface of Venus, but those didn't last very long. What happened to them? Well, that's what you're about to find out. Time to make your way down to the surface. Don't these clouds look beautiful? Well, don't inhale them. These yellowish bands streaking across the sky are clouds of sulfuric acid. If you could only get a whiff of them, you'd smell the reek of rotten eggs. But to do that, you'd need to remove your helmet, and I definitely do not recommend that. At a height of 50 kilometers above the surface, visibility is poor. You'd hardly be able to see anything. The incredibly thick atmosphere would block views of this planet and its tens of thousands of volcanoes. The atmosphere is mostly made up of carbon dioxide, and because it's so thick, it traps heat on the planet's surface, keeping it nice and toasty. Just how toasty are we talking? You're gonna find out the hard way. As you descend another 15 kilometers, the haze would begin to clear. The world below would finally reveal itself. A rust-colored surface covered in mountains and volcanoes. Looks like this volcano is still active. You'd fly around a little to collect some samples and take in the view. Yep, the atmosphere is mostly carbon dioxide with traces of nitrogen. That checks out. Okay, well, let's see if you can land here. This looks like the spot.
Mission Control, am I clear for landing? Mission Control? Looks like there's no signal. Initiating the landing sequence without clearance. Fingers crossed.
Landing your spacecraft would kick up clouds of dust that would take several minutes to settle down in the soupy atmosphere. As it clears, you'd look up into the sky, but you wouldn't find the familiar yellow circle of the sun. On Venus, it always looks like dawn, no matter what time of day it is. That's because the Venusian atmosphere only lets about 10% of the sunlight that hits it reach the surface. But wait, what were we saying earlier about the space probe that landed on Venus? Oh yeah, Venera 13. This Soviet probe made its fatal landing back in 1981. It survived the descent and lasted for a whopping 127 minutes. That's longer than any other spacecraft that had made it to the surface. But then, Venera 13 gave way to the violent, uninviting environment of this hell. It was likely crushed under extreme pressure. Or it melted. But it's too late to turn around now. You've lived through the 1 hour long landing and you're so close. All you need to do to complete your mission is to spend 5 seconds out there. Yeah, out there. In the most extreme environment you've ever been to. You made it! Whoa, the atmosphere is so strange. You can hardly lift your arms. Even though Venus has about the same gravity as Earth, you'd be feeling the sheer weight of its immensely dense air. It would feel like you were walking through water. Very hot water. And you'd be glad you were wearing so much protective gear. A quick look at your thermometer would tell you that it's a sweltering 475 degrees Celsius out here. That's hot enough to melt lead. Your pressurized suit would be working hard to keep you safe. Without it, you'd be crushed under all that pressure before you could even complete your mission. This isn't so bad after all. Hey, if a spacecraft could last over 2 hours, some 40 years ago, well, you and your shiny new gear can survive longer, right? Venus is right here for you to discover. Just take a few more steps. Suddenly, something distracts you from the first ever first-hand human analysis of Venus's surface conditions. Your protective suit breaks. The drastic pressure shift would immediately make you feel like you were deep underwater. With an atmospheric pressure 90 times that of Earth, Venus would be crushing you from all directions. At the same time, you'd be struggling to breathe in an atmosphere without any oxygen. Any atmosphere you did manage to inhale would scald the inside of your mouth and the top of your throat. Unless you could scramble very quickly back to the safety of your spacecraft, you'd be dead within seconds. Hey, it could be worse. High above you, sulfuric acid clouds would be raining acid. But in this unbearably hot environment, the toxic rain wouldn't reach the surface. It would evaporate long before that. So at least you wouldn't have to worry about acid dissolving your skin and bones. That would be kind of gruesome. You know, in hindsight, maybe we shouldn't have sent you down to explore this hellish surface. We probably should have terraformed Venus into a more hospitable planet first. But that's a story for another What If.
Here we are on Venus.
Gorgeous,
Okay.
beautiful Venus. Let's look at this
Okay,
thing.
first thing you're gonna notice, make it go. Is it?
Oh, you want to see it spin?
Yeah, let's see it spin. Because here's what I wanted to point out to you at home.
I wanna
Look at this. Look at this. Look at where Venus is spinning.
It's kind of
What do you notice? It's not spinning the same way as everybody else spins.
It's going the other direction.
It's
Just realized.
yeah, it spins backwards.
You can really see that speed when we turn the clouds
That's
on.
fast. So what's that speed?
Currently we are spinning. How fast are we spinning? 1 to the power of 10. 1 times 10 to the power of 6 times our normal speed, which is about 1,000,000 or 100,000 times faster than time goes regularly. So this thing's going fast.
1,000,000 times faster than.
Yeah, so we're gonna slow that down a little bit.
Jeez.
But what's interesting is like seeing these clouds. Okay? You can really notice like those clouds make a big difference.
Wow, did they ever?
Feeling
Yeah,
that
yeah.
speed. We're gonna keep them off because it looks more beautiful.
So the thing about this that I was going to point out, because Stu, I know you love sunsets, and you haven't started to show me the sunset yet, but I'm sure you're going to at some point. The sun rises in the west and sets in the east because it's moving backwards.
Interesting.
Backwards to us,
Yes.
relative to us.
It's retrograde.
It's kind of its own way to spin. So make it. Can you make it spin?
Yeah. So as we increase, it's gonna take a lot.
Oh, because
for
it
us
does.
to
It's
see
we have to see it, right? Okay. So
300 times normal speed, 100 times, 3,000
and I still don't. I don't see it moving. There we go.
30,000 times we can actually start to see it, and that's just on the clouds. We turn those clouds off.
Turn the clouds on. Is that on and that's off?
This is off. and-
Right. Okay.
but-
Now let's see the spin.
And now this is where we can actually see it. But if those clouds are off, we still can't really even feel
What
it.
do you notice about it?
It's pretty slow, Peter.
Well, you had to
Parts.
speed this up to show how fast it was spinning, and
So
it
if
really
we
you
go
couldn't
back
really
to
see it.
normal speed.
You want to see how fast it spins? Boring.
That's about
it's
how
so
fast it
boring
spins,
on
Barry.
Venus. You know why? Because one day on Venus, one full rotation of Venus is 243
Earth days.
Earth days.
I'm noticing this. How long to orbit? It's actually less. I'm seeing 224 days to orbit the sun. Is that true?
224 days to orbit the sun, 243 days
For a full
for
rotation.
a full rotation. So one Earth day is 243 No, 243 Earth days is one Venusian day.
Yeah. Oh.
Yet
Oh my.
a Venusian year is 224.
Days. Almost 225. Let's round up. That's what I'm seeing right here.
So 243 Earth days for a day, 25 Earth days for a year. Yeah, you could be 10 years old, but you're really only 8 days old? What, 15 days old? Something like that.
Yeah.
You do the math, leave it in the comments.
Peter, I'm just realizing that people are only getting sunrises and sunsets not even once a year.
Right, so
And
you
honestly,
would probably
that
get
is-
one every year, but every 10th year, 12th year or something, there would be no sunset, no sunrise.
It'd be like an awful leap Venusian year.
Wait, you would get one sun because you get a sunrise in half of that time. So if a day is 243 Earth days,
I think we're diving too deep.
We're going
into
too deep
it.
into this.
You know what? It's really cool. Let's look at the sunset and the sunrise. You know.
okay, as you load that up, I'm just going to tell you that the sun affects Venus more than Mercury. In fact, it's hotter on Venus than it is on Mercury.
That is really interesting.
I'll tell you why. It's because they have an atmosphere that traps carbon dioxide and traps the heat.
All right, so I like that, and I want to show you something.
Interesting fact.
It's a great fact, Peter.
Okay, but you want to show me something from the surface. What's it going to be here?
Well, what I want to show you first is talking about that atmosphere. This is what it would be like if this was like, if Venus was like Mercury. No atmosphere, just kind of like sitting out in space, hanging out. We put an atmosphere on it. Watch what happens. Boom. Look at that.
Cool.
The atmosphere is completely different. But I'm not done yet, Peter.
No, this is like Ukrainian flag almost.
Yeah, it's a beautiful yellow and blue.
Yeah.
And I'm going to throw on clouds, and I want you to tell me what's the first thing you really notice.
Can't see the sun.
Gone, absolutely gone, and that's one of the big things to notice on Venus.
In fact, that's the only thing I really noticed. Was there more than one thing that I should have
no, it was
noticed?
mostly that. But
Kinda
I
a
just
trick question?
Yeah, it's throwing you up
Yep,
there. You
got
know,
it.
You
Okay.
worked perfectly.
Okay, and tell me why that is. So the clouds block out the sun because they are so thick?
So thick, so prevalent on Venus. If we were to back out and really look at those clouds, look at what happens when I turn off these clouds. You can see the beauty of Venus.
I don't really see the beauty, but I can see the actual surface.
Venus is beautiful to me. Okay. And
Venus, is that why they named it Venus, the goddess of love?
possibly. I don't know. Maybe
Because
one person
it's
saw
beautiful?
this and saw it was beautiful. No, because when they looked through a telescope, this is what they would see.
Ah, like the
Whole planet full of clouds.
porcelain-colored skin of Venus.
And what's really bad about this is that these clouds are, I believe they're sulfuric. Is that
Well,
correct?
the air is mostly carbon dioxide. The clouds are sulfuric acid. You're right.
Ooh, that is terrifying, and honestly,
Yeah.
might drop my scale.
Well, and you know what else? The winds up there in the clouds.
Yeah.
200 miles per hour.
200
Yeah.
miles per hour. That
Yeah.
sounds very fast.
The Earth clouds that we see, Earth clouds,
Yeah.
50 miles an hour.
Ooh,
Yeah.
that is so. These
So
things are going
4
four
times,
times
yeah.
faster, which is what we were kind of seeing when it was spinning around. It's just how quickly that is.
Yeah.
So why don't we look at the sunset and you tell me what you're feeling?
Okay.
Now remember, this takes a long time for it to go down, so I'm
So
speeding
you're
it
gonna
up.
speed
like-
it up.
like
You usually
crazy.
do, right?
I love to speed it up.
This is 30,000 times speed.
Yep.
30,000 times speed, and it has to be because. Oh, I see.
Look at that. Look at that beautiful blue. Stop
Oh,
right
yeah.
there. I think that looks gorgeous.
I like it. I like it a lot, and I like also that you can see this is what, as some sort of nebula in the background, or what is that?
Yeah, but well, here's the thing: if you were really on Venus,
That's what you're seeing.
that's what you're seeing. You're not really seeing too much. So we're removing that to add to the kind of beauty of Venus. So we're giving it a little bit of an extra edge. But keep in mind, like, these clouds are everywhere. They're constantly just blocking everything. So something to keep in mind for your rating.
Is there a sunny day on Venus? Always clouds.
I think there's almost always clouds. It's hard for the sun to come through. But you know what?
Depressing.
There must be, because it's actually because the days are so long. You kind of have
Yeah.
sunny and cloudy and rainy, and it's a long day.
It's a really long day, and I'll tell you one other thing. Because of the enormous atmospheric pressure on Venus, every square centimeter of your body has about 90 times Earth's atmospheric pressure pushing against it. So it's pretty uncomfortable. It's like being at the bottom of, or being about 1 kilometer below the ocean. That's how much pressure you'd be feeling everywhere on your body. And you'd probably squish out like one of those
Globfish?
blobfish.
Blobfish.
Yeah.
Blobfish. Yeah, those guys are...
And also it's pretty hot there. It's 465 degrees Celsius.
That's what I'm seeing right here. Average temperature,
465. And you know what temperature it is at night?
No, I don't.
465.
Wow,
Yeah. No respite on Venus. There's no break from the heat.
So I have to ask Peter, from all of this, we just did Mercury. What are you feeling rating-wise for Venus? Obviously, we have Earth coming up, so that might skew. But what are you feeling?
Earth is best. Venus is worst. I can say Venus is a 0.
0.
Yeah.
Really? Start 0 also?
All of that atmospheric pressure.
Yeah.
465 degrees Celsius.
Yeah.
Carbon dioxide atmosphere. Sulfuric acid clouds.
Yeah.
Oh, that's got a nice deep blue sunset. Okay.
It's a gorgeous blue sunset.
Yeah. So
I'm a sucker for sunsets.
okay, half point for Venus's sunset.
You know what? I'm gonna give it a 4. I'm gonna give it a 4. Actually, you know what? No, I take it back.
It's early in the game.
I take it back. I'm gonna give it a 2 because I can't even see the sunset.
Okay, favorite planet for me. I'm not giving away my rating yet, but Earth. 24 hours on Earth. Let's just wait this one out. We can do 24 hours on Earth.
Yeah, it works for me. Let's put it to real time.
We're doing it right now. You're doing it with us.
It's a very long live stream.
So far, so good.
How are you guys doing?
Leave your comments about 24 hours on Earth in the comments section, and maybe Stu will read them to me, and I will dictate my answer. That was a joke. We're not actually going to sit here for 24 hours on Earth, but we are going to explore Earth and maybe tell you some things that you don't know about Earth. Spittin' facts about Earth. Not much that you don't already know. You know about how many continents there are, how many oceans, breathable air, blah, blah, blah. Did you know it's the only planet in the solar system with liquid water on the surface?
I did not know.
Well, you probably did know that. Otherwise, you would have... Maybe what? Do you think Neptune has liquid water on the surface?
I mean, yeah, if I think of it, I was just trying to make you sound a little bit
thank you
better,
very
but
much
you
for that.
kinda just threw me
Length
under
of
the
day,
bus there.
24 hours. Average temperature, surprisingly, 15 degrees Celsius. And that's 59 degrees Fahrenheit. That's the average temperature. I guess, you know, for those of you who live closer to the equator, you wouldn't believe that. But for those of us who live north of the equator, yeah, that's believable. We've got an atmosphere. It's very important to have an atmosphere because
We can see that atmosphere
Yeah,
all
okay.
around.
it protects us from solar radiation, protects us from solar winds and things that will strip us from our oxygen, the gases that we need and the water that we need to breathe and live and blah. And we have active weather and oceans and plate tectonics, and you know, some places have. And Italy, that's nice.
It's gorgeous.
Yeah, I'd like to visit Italy at some point. Florence is on my list.
You've never been to Italy?
I've been to San Remo for half a day. I took the train from France through the Riviera to San Remo.
It's gorgeous. That's the next What If episode. What if Peter goes to Italy?
What if? Let's follow me on the URL. Let's give this rating. Earth, let's rate it.
Yeah.
I'm gonna give it a 10. Because it's the only place I can live.
Yeah, it's a 10 out of 10 for me. Look at that.
Yeah,
The sun is
it's beautiful.
gorgeous. And
It's got butterflies, maple syrup, beautiful sunsets that Stu loves,
I thought you were going to say
fresh water to drink, salt to put on my steak. Like,
I thought you were gesturing towards me like I'm on this planet, but you kind of gestured past me to sunset. So
also,
we'll move on.
it's fun to be on a planet with Stu.
No, we'll move on.
It's
okay. You don't need to pity me. It's fine.
Fun place to be. All right, next. Wait, did you rate it? Yeah, you give it a 10 too.
I give it a 10.
Next.
Ah, Mars, the red planet, and our potential new home. Well, Mars isn't as hospitable as it sounds. It's really inhospitable.
It might be a balmy 20 degrees Celsius during the day, but at night, the temperatures can drop to minus 153 degrees Celsius.
Okay, if you don't know what minus 153 degrees Celsius is, it's intensely cold. It's like minus 243 degrees Fahrenheit. It's the type of temperature that will give you frostbite in seconds. In minutes, you'll die from hypothermia. Seriously, guys, learn the metric system. Also, we do the conversion for you in the closed captions.
And if you think Uranus smells bad, well, that's because you haven't been to Mars yet. Yeah, the red planet smells like rust and gunpowder.
But when I wear my helmet, all I smell is me, and I smell pretty good. Most of the time.
Well, you wouldn't be able to breathe on Mars anyway. The planet barely has any atmosphere. Most of it is carbon dioxide with only trace amounts of oxygen. Luckily, this time we aren't sending you to Mars. We've decided to sacrifice Chase for this mission.
What did you mean by sacrifice?
I mean send. We sent Chase up to set up a base on Mars and report back. Hey, he made it! Welcome to the Red Planet.
Kinda nothing here, huh? I thought there'd be more stuff, you know, Rico? Any ideas?
I detect no breathable air, high levels of radiation exposure, low pressure, and frequent dust storms. If you want to survive on Mars, you must build a habitat.
Great idea. How long will that take?
With the materials you transported aboard the Starship, I calculate it will take about 3 months to assemble a simple base.
That's not so bad. I better get moving.
Now, building a habitat on Mars wouldn't be so simple. It's got to be airtight and insulated to protect Chase from radiation and Martian dust storms. It also needs to have a sustainable life support system to manage air, water, and waste. And, of course, Chase will need to get power from solar panels.
You don't want to know where I get my drinkable water from. But I'll tell you anyways. I could extract water from the Martian soil or atmosphere, but it's so much work. Instead, I recycle water from things like sweat and pee. I just try not to think about it.
The sensors are picking up a micrometeorite headed straight for the base. Potential hazard detected.
Don't sweat it, Rico. We got enough water. Base is fine. I built it myself. Here, let me give you a tour of my crib. Welcome to the fanciest pad on the planet. Over here is where I sleep. And over here is where I eat. And over there is a window. And this is my luxury first aid corner, in case I get hit by like a dust storm. Those babies travel at like 100 km/h. They could easily slice through my spacesuit. Oh, you gotta see my Michelin star greenhouse. It's 5 stars because it's rated out of this world. It's my favorite place in the base. Only thing is, I had to build it unattached to my main living quarters because Rico forgot to include a tunnel in the first base plan. So now every time I gotta go check on my plants, I have to go outside. It's exhausting. That's why I don't bother to take off my helmet when I pop into my habitat. I'm all about efficiency. Plus, it's a lot to animate, actually. Check out these potatoes. They look pretty good. Take that, Matt Damon.
Micrometeorite is approaching the base. I calculate the chance of it striking the habitat as 87.42%.
Rico, silencio, por favor. I'm recording a YouTube video, my friend. Come on, and what did I tell you? Round the numbers. Okay, where was I? Oh, yeah, potatoes. It takes a lot of work to grow anything on Mars. Taters aren't my first choice. I'd grow burgers if I could, but we work with what we got. I keep my greenhouse nice and pressurized and at a comfy temperature of 16 degrees Celsius. And for those of you who hated the recycled pea stuff, you're gonna love this next part because as a fertilizer for the Martian soil, I use a super special ingredient, my poo. Not because I'm a sicko, but because Martian soil is literally garbage, figuratively speaking.
It smells pretty bad in here. Ugh, but at least it doesn't smell as bad as Uranus.
Danger. Micrometeoroid has breached the habitat. You must go there immediately.
What? Ah, damn meteoroid. Sorry guys, I gotta go check this out.
Your helmet has sustained minor damage.
This is my favorite helmet. Rico, do I have a spare somewhere?
You have an extra helmet, but I have bad news.
Uh-huh. What? What now?
The extra helmet is back at the habitat.
Of course. Of course it is. Are you kidding me? 3 months on Mars! And I just finally start getting this thing working and Mars has to ruin everything! Well, at least I have tape around here somewhere. Be back in a minute. Here, this should work. Rico, how's that storm looking?
Not good. A dust storm of this type, it can last for days.
Oh, great. That leaves me no choice. If I don't make it back in time, I'll lose everything and die. And I can't die now. I just finished building this sweet, sweet bachelor pad.
It's only a 5-second walk for you to reach your living quarters.
Okay, come on. It's only 5 seconds. You can do this, Chase. You can do this. Get your head in the game, boy. This helmet is useless. I'll go without it. 5 seconds to get back home. I can handle a little bit of frostbite.
I highly advise you don't do this.
Okay, well, if I don't make it, I'll see you guys on my next adventure. Chase out.
Looks like the atmospheric pressure killed him before the frostbite could. Didn't I say going out there without a helmet was a bad idea? Yeah, don't try this on your own.
So Mars is obviously something that's constantly being talked about. It's in the news. It's one of our escape planets, possibly. There's been a lot of movies made about it. Matt Damon grew potatoes on there with his own poop. It's called the Red Planet for obvious reasons, because
of the poop. Yep.
Yeah.
It's red because of the debris and what's on the planet known as the Red Planet, and it's absolutely, honestly, I find Mars gorgeous. I'm gonna say that right.
Yeah, that's something I expected you to say.
Is that?
It's not really a surprise to me. It's very much Earth-like, Mars.
Yeah.
Almost the same length of a day. I think it's 24 point. Do you have it there?
Yeah, actually, you're 37 to 39 minutes. So
Yeah.
it's slightly more. You get that extra half hour to sleep in. You know?
Yeah.
It's pretty nice.
Average temperature minus 65 degrees Celsius, so very similar to what we live through in Canada. Just kidding. But it was a long winter. So, and what else can we measure? It's still within the habitable zone, really, isn't it?
Yeah.
1.5 astronomical units away, so just half an astronomical unit more than Earth.
Yep.
Away from the sun, that's what that means.
And we're also noticing that it takes a little bit longer because, it's farther away, but not too much longer to rotate to go around the sun.
To orbit the sun, so 1.8 years, 1.8 Earth years to get around the sun.
Yeah.
So that wouldn't kill you. The frequent dust storms might kill you. It's pretty windy up there and lots of dust blowing around.
Yeah, let's turn on these clouds. We kind of see these are those clouds.
You saw that in the Matt Damon movie as well, after he was growing the potatoes. So what's really cool about Mars is it has mountains, just like on Earth, and actually on most of the other planets have mountains as well. But this has the tallest mountain in the solar system.
Entire solar system.
Some
You can
people
see it from space.
Jeez.
Right there.
If you're Greek, you call it Mount Olympus. If you're not Greek, you call it Olympus Mons.
Olympus Mons. It's absolutely gorgeous.
And let's have a look at it. It's let's see. It's pretty wide across, but the most impressive part about it is how tall it is.
Yeah, so that's going to be hard to see while we kind of dive into here. But, if we were to dive onto the planet.
You know what would be really cool? I don't know if you didn't do that.
That'd
Go
be cool.
back.
Now you got to go back and reset this whole
It
thing.
doesn't take that long.
But what
Look,
I was
we're
going to say
back.
is if this program had like a tape measure thing where you could just put your cursor here, stop.
Oh.
You just put your cursor there and dragged it to the other side of the thing, and it would read out how wide it is.
That would
be
cool.
good.
Maybe
So-
you can't. I don't know how to.
Okay, maybe
Maybe
it
it's
does.
just a
If not,
user error thing. Let us know in the comments.
let us know in the comments if you think that can happen and how we do it.
But I think it's really interesting to note that, like, if we were to back out and we were to look at Mars as a whole, you can really just see how big this singular mountain is the fact that we can go like this far away from Mars and still see it as, you know, a splotch, a beautiful splotch on
It looks like a
like a pimple or something.
birthmark or a pimple, yeah.
Yeah, this is gorgeous, but compared to Earth, like compared to Mount Everest, just how big is this thing, this Olympus Mons?
Well, first of all, I'll tell you, you can kind of see the shape. It reminds you of one country in Europe that you might know, France, and it's about the size of France. If you're not familiar with France, if you're from the United States of America, think the state of Arizona. So that's about how big the base of this is from edge to edge. That's Mount Everest.
Yeah.
Tilt your thing so it's like a
Oh,
peak.
so it's a mountain.
There's the
Okay,
peak.
yeah.
That's Mount Everest.
Yeah.
This is Olympus Mons.
It's very scientific.
2.5 times, maybe 3 times bigger than Mount Everest.
We can also see just this is just fun for you, Peter. This is a giant canyon
Oh yeah.
throughout that we can kind of see.
So looks like the Grand Canyon
Looks like the Grand Canyon, much bigger.
without all the tourists.
Maybe there's tourists in there.
There's no Rio Grande.
Could
Rio
be.
Grande.
But as you can see, it's almost like a scar across.
Yeah.
It's gorgeous, absolutely. Gorgeous.
Now that would signify to me rivers.
possibly, you know, I mean, water on Mars has been hotly talked about for a very,
Or
very,
coldly talked about because it's actually water ice there now. Ice is something we're very familiar with, and it's always made out of water here on Earth. So if you're going to say ice to me, I'm thinking water. If you want to say a different kind of ice, say a different kind of ice, nitrogen ice or blah, blah, blah ice.
If you say ice to meet you, I laugh.
Ice
That's
to
pretty
meet
funny.
you. Okay, so I've just fertilized.
Let's slow that down a little bit.
Okay, so I've just fertilized my potatoes,
Yeah.
and it's time to take a break.
And you're gonna take in this beautiful sunrise.
Beautiful sunrise. Actually, I'm probably pretty tired. I'm gonna go back to the ship and have a nap because I was out early with the potatoes. But then I stop and I'm all of a sudden fascinated by this sunrise on Mars.
Is there something interesting that's catching your view? Because I can tell you what's catching me is that we call Mars the red planet, and as we go higher, we see that red kind of come in there. But then when we come back down here, I'm not seeing red. In fact, I'm not even seeing red near the atmosphere. I'm not seeing red at all. I'm seeing a lot of blue.
Can I take a guess at this?
Yeah, go for it.
Because of the quote-unquote atmosphere, the non-existent atmosphere, but the gases that are on Mars, the sun is pushing through all this gas.
Yeah.
And the molecules in the gas are refracting all the light, and it's pushing the red light to the side and letting all the blue through. Because it's coming at an angle that it's pushing through a lot of gas. I'm standing here and it's pushing through a lot of gas. But as it gets higher, it's just going directly through. So it's not pushing through as much gas. Good guess, bad guess?
So I would say you're very close, except not about the gas. In fact, tell me about like how Mars has these different seasons.
Well,
and
yeah, I was just going to bring that up when you were talking about that. What happens with Mars is it has an irregular orbit. So instead of going in a circle around the sun, it goes like in a half circle around the sun, and then it sort of wows out into an elliptical orbit. And so overall, the whole thing kind of looks like egg-shaped, kind of like rounded at the bottom and then elliptical at the top. So, and because it's getting further away from the sun at that time, that's a colder season. So we really have 2 seasons on Mars. You might as well say summer and winter. One where it's cold, extremely cold, and one where it's not so cold. Kind of like Canada.
interesting.
2 seasons.
And so let's why don't we finish this off and let's do a rating on what you're feeling about Mars, Earth's cousin, that many people like to describe.
Earth's cousin. Well, I think Mars has to be highly rated because we know a lot about Mars. If you're just talking about this visit here, not that impressive to me, but over the years we've, swallowed a lot of information about Mars. And Mars is supposed to be, our getaway planet when we ruin the planet Earth, as we were going to. So 2 seasons, not terribly cold.
Yeah.
You can stand on its rocky surface. We kind of have it mapped out at this point. You can grow potatoes if you've had a big dinner the night before. You can poop out some fertilizer.
And what do you think of the sunset right here? Sunrise.
Really?
I'm surprised.
Okay, where are we coming from? We're coming from the king of sunrises and sunsets, Earth. So this, it's neat. It's different. Blue to red eventually.
I think that's pretty cool.
It's pretty cool. But I think Mars is a pretty good planet. I wouldn't mind spending 24 hours on it, and I would probably give it 8 out of 10.
You know what? You talked a lot of meanness about Mars. You left it with an 8. I was gonna give it an 8, and I felt like I was being fairly positive. I was expecting a 2 from you, but
I mean, here's the thing. There's not a lot of options in this solar system. Like, there's no other planet with trees and with lakes and whatever.
The bar is low.
But this is something we could actually walk on, possibly survive on if we do it right, and it's not dissimilar to Earth. So 8 out of 10 for me to poop on.
Is that a reference?
Do you know that?
That's Jupiter. And guess what? Nobody knows exactly what it's made of. But today, we're gonna fix that, because I'm jumping straight in.
Would you like me to pull the information I have on Jupiter's composition?
No, not now, Rico. Okay, so there are some things we do know about Jupiter. For example, the fact that it has 5 layers. Rico seems to think I won't make it past the 3rd one, but I'm gonna prove that silly robot wrong. I mean, I have to, because once I get to that last layer, it's gonna make me rich, baby. Space rich. And all the while, I'll be filming some epic, never before seen footage for you guys. Nothing can go wrong. Ow. Okay, we're heading off to Jupiter in a bit. I just have to refuel first. Rico, was there no other moon to make a pit stop? Ganymede is like so freezing out here. It's like a minus 130 degrees.
Despite its sub-zero temperatures, Ganymede is an optimal landing choice, as it is the only moon in the solar system with its own magnetic field.
Fine, well Jupiter has the answer to my refueling problems forever, so long as I get to its mystery core.
It's true that we don't know for sure what Jupiter's core is made of, but we do know that Jupiter is the largest and oldest planet in our solar system. It has more than twice the mass of all the other planets combined. And with a radius of 70,000 kilometers, it's 11 times wider than Earth. This planet is also a gas giant made up of the leftovers from the formation of the Sun 4.5 billion years ago. Visiting Jupiter would be nearly impossible because it's almost 800 million kilometers away. That's over 600 times the distance from Earth to the Moon. While we've sent robotic probes to explore its mysteries, sending humans there? That's another story entirely. Right now, the biggest obstacle to reaching far-off worlds like Jupiter isn't just the distance, it's the lack of propulsion systems powerful and efficient enough for such long journeys. Current technology simply can't get us there safely. But what if we could harness cutting-edge nuclear technology to change that? Well, lucky for us, one company called Nano Nuclear Energy is already working on a solution. They're redefining what's possible with micronuclear reactors. These are compact power systems that could transform space exploration.
Nanonuclear's reactors, like the Zeus solid core battery reactor and the Odin low pressure coolant reactor, are more than really cool names. They're designed to be portable, efficient, and incredibly powerful. Nanonuclear Space, a subsidiary of Nanonuclear, is exploring how this cutting-edge technology can play a role in humanity's journey to push beyond low Earth orbit. Their reactors could provide energy for spacecraft propulsion and human-sustaining habitats on other planets. These compact reactors can generate between 1 and 20 megawatts of thermal energy, which can be used directly as heat or transformed into electricity. But Nanonuclear's innovation doesn't stop there. Their technology is also revolutionizing things down on Earth. The small size and portability of the Zeus and Odin microreactors make them perfect for remote communities that lack access to the central power grid. Plus, they can be deployed and removed quickly, making them perfect for disaster relief efforts. Nanonuclear is thinking big by going small. They've teamed up with Everstar AI to create an AI-powered compliance solution aimed at making nuclear power safer and more efficient. And with $125 million of cash on hand, they're ready to turn their vision into reality. Clean, portable nuclear energy that can fuel our planet and even take us to the stars. Check out the link in the description to learn more about their journey and imagine how their technology could one day help us reach the big red spot of Jupiter. Until then, we'll just have to send Chase there.
Oh, damn! Rico, Jupiter has a massive freaking pimple! Let's land there.
Warning, the Great Red Spot is a high-pressure anticyclone in Jupiter's atmosphere. Winds there reach speeds of 680 kilometers per hour.
Of all the places on Jupiter, the Great Red Spot is the last place you want to fly into. It's a storm that's been raging for at least 300 years. It's a lot bigger and a lot scarier than anything you've ever experienced on Earth.
I'll just approach it hurricane style and fly right down the center. It'll be fine. This is it. First person to ever fly into Jupiter's big red hole or whatever. Here we go!
Warning, temperature rising rapidly. Atmospheric temperature over 1,300 degrees Celsius.
Rico, what's going on?
System overheating. Cooling system.
Rico? Rico, you know I don't like pranks. Stop messing around with me, man.
This raging storm is so powerful, it creates sound waves that heat particles in the atmosphere and make this area 1,000 degrees hotter than the surrounding atmosphere. So, if you land here, you can count on, well, some discomfort.
Okay, I can fix this. Oh, no. Oh, gosh, okay. These winds are way too strong. You know, if I close my eyes, it kind of feels like a roller coaster. I'm having fun. This is fun for me.
Jupiter's clouds are mostly ammonia and water. Because the winds on Jupiter are so violent and flow in opposite directions, they shape the clouds into conveyor belts around the gas giant. Some of the clouds reach speeds of up to 500 kilometers per hour. Not that you can avoid them now, as you've already plummeted into the raging planet.
Okay, wow, it's so cold that the ammonia is freezing into ice and hitting me in the face. Cool. Ouch. Rico, please come back. If you come back, I promise I'll never be mean to you again. Huh? Oh, finally! Rico, you can't just take a siesta in the middle of the day, okay? We're not in Spain. We're in space. Now propel me to the second layer of the atmosphere. Idiot.
Propulsion commenced.
Oh, what is that smell? Rico, did you fart?
Negative.
Did I fart?
No one passed gas. At hotter temperatures, the ammonia in the clouds combines with the sulfide compounds to create ammonia hydrosulfide. which smells a lot like rotten eggs.
Oh god, it smells really bad in here, Rico. Maybe alien life does exist on Jupiter, except they all died a long time ago. Or maybe somebody hotboxed Jupiter with a bunch of burning trash. Ugh.
No, it's just the ammonia hydrosulfide.
Oh god, this sucks, Rico. Let's go to the next layer, quickly.
Depth reading. 200 kilometers below Jupiter's clouds. You are now in the outer interior. Atmospheric contents include hydrogen and helium.
Oh, chilling with some pretty standard stuff then. Hydrogen, helium, one cool as hell guy. It's just getting a little hot.
Pressure reading. 3,039.75 bars. Temperature reading. 1,890 degrees Celsius.
It's so hot in here. I'd take the suit off, but then I'd die, so no thanks. Not dying like that again. I don't know how much pressure my camera can take because it's like the air, it's getting all weird and liquidy. This feels very tight in here.
Imagine 100,000 cars stacked on top of you from every direction. That's what it feels like as you approach Jupiter's interior. The pressure is so intense that even hydrogen atoms can't withstand it. Under that immense pressure, hydrogen atoms shed their electrons and form a charged, electrically conductive liquid. Think about what that can do to the atoms in a human body.
Think about it? Think about it? I'm living it, baby! And it hurts! Ow! Rico, quick! Bing! Cures for lungs being crushed by unreasonable amounts of pressure on WebMD.
No cure available.
Okay, search the Facebook comments.
Negative. If left untreated, you will experience inevitable death via liquidation.
Oh, God! Oh, I'm gonna be sick. Rico, open the space sick valve.
There is no spacesuit sick valve in this model.
What? What kind of crappy suit doesn't have a space sick valve? Ah! Oh, man. I feel really sick to my stomach.
Nausea is not a symptom of high pressure.
What?
Yeah, maybe I should have mentioned earlier that the charged liquid hydrogen paired with Jupiter's rapid rotation creates one heck of a magnetic field. It accelerates charged particles to such high energies that anyone who enters Jupiter's magnetosphere is exposed to toxic radiation immediately. Luckily, Chase's spacesuit is strong enough to delay the effects for a little while.
Great. So it's a race to what'll kill me first? The pressure, the radiation, or those droning voiceovers? Luckily, I've managed to make a few upgrades to my suit along the way, so I should be able to last about another 15 more hours. Rico, let's get going. What if guy, feel free to stay behind.
Warning, you are entering uncharted territory.
Wow, don't be mad, Rico, just because you thought I'd be dead at this point. I can't see anything. Rico, activate the augmented sensory system.
Activating stage 1 of ASS.
And this is why I decided to come here. This is metallic hydrogen. If I collect enough of this stuff, I'll be richer than Jeff Bezos.
You can collect enough metallic hydrogen to power your spaceship for 2 billion light years and repay all your burger debt. Leaving now would provide just enough suit resources to make it out alive. This could be your first successful mission.
Yeah, I mean, we could leave, but we're so close to the core. I'd be the first YouTuber ever. Let's just pop in for a quick check.
Unintelligent idea detected.
Rico, I'm so bored. Are we there yet?
You've been sinking for 4 hours. You have 8 more to go.
God, I'm so bad with time management.
Also, you have less than 9 hours of suit protection left.
Well, I guess this is a good time to tell you guys to go like and subscribe. I'm trying to become the first YouTuber to explore all of space, so, help your boy out. If you like and subscribe, we can go do more of these cool videos.
Approaching the planet's core. 5 minutes of suit protection remaining.
Okay, gotta move fast. What do we got down here? Some sort of like crazy alien life or super weapon, maybe like a Stargate or like some crazy super material.
Detecting ice, rock, and metal.
Okay, that sounds like stuff you could find on Earth. Maybe I need a second opinion.
Jupiter's core was made over 4.5 billion years ago during the creation of our solar system. Due to the extreme pressure and temperature, the core is not a kind of hard surface you might walk on. It's pretty liquid-like.
30 seconds of suit protection remaining.
You know what? I don't want to hear any of this negativity, Rico. Just get me out of here, okay? Activate the specialized upflow cyclone kit.
Suck not available. Suit protection failing.
The suck sucks. And why is it so hard to breathe and so hot all of a sudden?
Your suit protection is now depleted. You are now experiencing a pressure of 43,090,032 bars and a temperature of 29,095 degrees Celsius. The intense conditions are quickly crushing your lungs.
You know, you get crushed along with me, Rico.
This one's called Jupiter. And you know how I know?
How?
Is that the big red spot?
That is the big red spot.
Doesn't look so red on this computer.
Yeah, let's bump that up a little bit.
What the problem?
It's just a little bit more orange, but it's great, and it's a spot.
It is a spot. Let's just jump right directly into the spot because that's what kind of makes this planet so identifiable.
You want to jump on that?
We could jump into it, sure. I just wanted to talk about it since we were right there.
There's your red.
Wow, so there's the red, yeah. So you see that spot. We'll see it when we get back out. But if you just saw the spot, you saw it was called the big red spot. Didn't look enormous compared to the size of the planet. Stu's gonna pull it up at any second. I know he can do it.
I accidentally went to
He's trying to.
giant star.
It's on that line there.
You know,
somewhere.
I had it there, but you made me go on the planet.
Right. I didn't make you do anything, but there it is. So there it is. Now, it looks like if this was the planet Earth,
Spin it around so you can.
what does that look about the size of if you're on planet Earth? Not even Australia. It looks maybe the size of Colombia. But you know how big it is?
How big is it?
Well, you could fit the entire planet Earth inside that spot. Still have room to spare. 2 Earths. You fit 2 Earths. I do think side by each is how you would fit them.
Yeah, that's perfectly acceptable.
And you know, you know what this is too, right? It's not a spot. It's not like he's wearing a sweater with a design on it.
No, although it would be a great design.
Yeah, they are wearing a coat of gas clouds and storms. You can see all these round things. They're all storms. And the big yellow, red spot,
As red as we can make it.
as red as we could make it with our limitations,
Yep.
is a storm that's been happening for a minimum. It's been observed for the last 190 years. This storm has been going on.
That's a long time.
There have been storms observed similar to this in that similar spot for 350 years. So whether it's the same storm or whether it's that other storm died down and another storm popped out, very, very possible. Look outside your window, storms come and go. This may have existed forever, for all we know.
Yeah.
Like this may be a billion-year-old storm.
We can, and we won't really know because we send a probe in there.
It gets
It gets stormed.
gets the gas face.
Yeah, it's done. So it's gorgeous. In fact, it's so gorgeous.
It's
so
so gorgeous.
gorgeous.
How gorgeous is it, Stu?
Why don't we jump down and see the sunset from there? Now,
From the spot, the exact spot, or
this
just
is
from?
the exact spot. Now, you might notice something a little bit different kind of going on here. This is a pretty flat planet that we got going on here, and that's mostly because we can't go that far down. Jupiter, as you know, is a gaseous planet, and so this software unfortunately does not let us go down all the way. So
Right.
what we're on right now is its first layer of clouds.
Okay.
It's kind of like we're up near the stratosphere of Earth.
And this is all hydrogen and helium.
Yes, so that's kind of what we're seeing in this atmosphere. So we're gonna see if we were actually be on Jupiter, storms, gases everywhere, like it would be absolute pandemonium. So instead, we're just gonna see a beautiful sunset.
Okay, let's watch. It seems like you're obsessed with sunsets here, Stu.
I can't help it.
I mean, I like them, but
That's kind of all I do.
you're really harping on the sunsets.
Well, we got a bunch more to go, so
Okay.
I hope you like them too. So why don't we sync this and why don't we flip it back up and you tell me what you think of this sunrise?
This is a 30 times regular speed.
Yeah. No.
I like it.
Gorgeous.
It's cool. Okay, I'll give you that.
Yeah.
Gorgeous.
See.
I like that
Now
it's
I
like
sunsets.
almost all one color.
Oh, that red.
Yeah,
Some
and it
great
doesn't
red
really
spot.
change. Well, that's that. Oh, so it would be different from a different position. Now the green,
No.
kind of don't care for. Green and orange. Could you imagine wearing that out?
I don't know. This right here. This is a great color scheme. That's a great shirt right there. I'd wear that.
That's a good shirt. Yeah, yeah. But just the green and orange. If you backed it up a little bit, it was kind of gross. Giving me the willies.
Oh, like this kind of.
A little further down, like yeah, you don't. Well, I guess you could say that's cool. But like what you had earlier, or a minute ago.
So you're saying you don't like carrots? Is that what you're saying? That's just green and orange.
Right. It's the carrot rise.
Yeah, that's gorgeous. I like carrots. What's really interesting is the rotation period here, or about how long it takes a full day, because it's much less.
Well, a full day is 10 hours or something, isn't it there?
Yeah.
I see. You've
9
got
hours,
it there. 9:55.
29.71 seconds.
It is
what this saying.
specific.
It's very specific. Now, this is obviously the render, so this is part of it, but roughly
Okay.
10 hours.
It's roughly 9 hours, 55 minutes, 29 seconds, and 71 milliseconds.
Yeah, give or take.
That's rough, yeah.
Yeah, it's pretty rough.
Yeah.
It's an estimate, but
Yeah, good.
it's just interesting that Jupiter, the biggest planet of our solar system, has a shorter day, substantially shorter day than Earth does.
Yeah, that's weird.
Yeah.
What is this white dot? See the white dot under there? Is that one of the moons or is that a...
Let's click it.
Okay.
This is Earth.
Oh, aren't we beautiful?
Look at that. So we can actually, why don't you want to go to it really quick?
Yeah.
You
Oh,
wanna
go
see-
to Earth?
Yeah, you wanna-
Back to Earth?
Yeah, you wanna see
We were
Earth
just
right
there.
Hey, we don't have to.
Not that long ago. We're...
Well,
Yeah. No. Let's, because we're carrying on outward toward Pluto. So let's keep going that way.
Okay, so
But I
go-
did think what I thought it was a moon. And I
Yeah.
know there's 90 moons on Jupiter.
It says 97 moons.
97 moons.
Wow, that is a lot of moons.
Anyways, what we wanted to get to, Stu, was to talk about how fast this planet goes.
Yeah, so if it's a 10-hour day, how fast is Jupiter spinning?
Oh, I know. Pick me.
I choose...
Stu, pick me.
I'll choose Peter.
43,000 kilometers an hour.
That is fast, but how fast does that compare to Earth?
Well, that sounds fast, but everything in space sounds fast, right? Earth is going 1,600 kilometers per hour.
Oh, so Jupiter's going fast.
Yeah, that is 30 times.
27 times.
Let's round that up. It's 30 times faster than Earth.
That's very fast. That's very,
27 times faster than Earth.
and that's why we're getting these really
That's why the day,
quick days.
even though this thing is, how many, do we have a diameter? Yeah, there's our diameter.
I'll put the little thing there. 139,000.
139, almost 140,000 kilometers across.
All right, quick. What's the area?
Do not know. Does
Does
not
not
compute. So it's a huge planet.
Yeah.
And yet the days are 10 hours.
Yeah.
Because it's spinning like a madman.
And what we're seeing here is it takes 11, almost 12 years to orbit the sun. So we're getting fast days, but those years,
So it's doing one of these around
Yeah.
the sun, right?
so a lot of days, but
It's dizzying.
But New Year's is very special on Jupiter. Peter, as we get to this sunset, what's your
Looking cool.
rating like?
Well, I've changed my mind on the sunset. The carrot sunset is intriguing to me.
Gorgeous.
And this red thing, it stays red. Even though it's a 10-hour day. Is this real speed? This is 30 times speed, right?
No, yeah, this is 3 times speed.
3 times speed, okay.
Remember, it's a 10-hour day. That's
No,
still
I
a
was
long
impressed
time.
how slow it was going because the day's 10 hours, so I thought it would go a lot faster.
Well, yeah, this is 10 times speed. So
Anyways,
going
it's beautiful.
pretty
So you
fast.
wanted the rating. So, okay. Great, huge, big planet. Has a distinctive spot. It doesn't really thrill me for giving it.
Really?
It doesn't, no extra points for a big red spot.
But sunsets are cool. The fact that it's not easy to live on. You live in the clouds.
Can't really live at all.
You can't really move at all. 97 moons, that's pretty cool. And you're going so fast. I don't know. It's hard to, like, it doesn't thrill me. This is not a fun, it's not a fun planet. You're not gonna be able to do anything cool on it.
It's true.
The sunset's cool, like you're showing me, but I give it a 3.
A 3, really?
Yeah, what's good about
I think it's gorgeous.
this planet?
I give it a 4.
Yeah, but are we rating it on how gorgeous it is? Or are we rating it on like how useful it is? And
We're 5 planets in. I feel like subjectively, it's just kind of
okay, okay. I stand by my 3.
It'd probably be even better if we were to look at it from one of its moons.
Oh, one of its 97 moons? Well, I'll tell you a couple of things about the moons. There's some major moons like Io, Europa, Ganymede, Callisto. I think what you're showing me is Io.
That is correct. And what's really cool is you're going to see these. Look at those spots, Peter. Those are volcanic eruptions happening right
Like
there.
seas of lava and magma.
Exactly. And as we kind of back out, first of all, you can really see the size of Jupiter there. Okay.
Well, it depends on how far away we are.
We're a moon, so we're far away enough. But,
Right. It's got a lot of mass and a lot of gravitational pull, so we could be far away.
What I really love is this.
That's cool.
You're seeing that.
Do you think that really glows in the dark like that? Like if you were in space? And
Probably not, because when we look from space from Earth, it's hard to see anything magma. But I think it paints the picture that this is how much is kind of going on Io right now. And as its sunset is taken by Jupiter, it is in full darkness, and then suddenly Jupiter's gone. We get that light that kind of comes back.
Go back a second. What is this big blue thing I'm looking at?
Where?
Go right there. What is the blue thing?
Let's look at. That is a nebula. That is Platus Nebula. It's 442
Light years away, and yet I
Let's-
can see it from Io.
Yeah, let's go there.
That's fantastic. It's going to take a while. Oh, you just traveled very quickly.
Yeah, that's how fast.
4.42 light years?
Gorgeous, right?
Yeah, it's pretty amazing.
Yeah.
I mean, we don't want to spend too much time on nebulas that aren't in our solar system
Because we
because
don't
our
have
whole
a
plan was
sunset.
to spend time on our planets.
All right, so let's.
No sunset. You also obviously don't care for that.
Welcome to Saturn, the most beautiful and violent planet in our entire solar system. Saturn is famous for its magnificent rings.
Saturn is the it girl of the solar system. What is the point of an accessory if it's not visible?
Ugh, thank you, Jace.
No problem. Thank you.
He does have a point. Scientists know a lot about what happens on Saturn, but they're pretty unclear on why. For one, Saturn radiates twice as much energy into space than it receives from the sun. That means it must have an internal heat source. Do we know what that is? Absolutely not.
Oh, I bet it has something to do with the composition of the core.
Well, Chase, we're sending you to find out. Yeah, that's right. Today, Chase is falling straight into the middle of Saturn.
Oh, see that cloud pattern on Saturn's North Pole? It's like a massive swirling hurricane, like the ones you have on Earth. But this one is shaped like a hexagon.
Hexagons, rings, Saturn has every shape.
What about triangles?
Not triangles.
Rectangles?
No more talking for you.
Circles?
Saturn's cloud hexagon is huge. It's 14,500 kilometers long and 29,000 kilometers wide. That's over 6 times the width of mainland USA. That should give you a sense of just how big this entire planet is. It's the second largest in the solar system and 10 times as wide as Earth. Oops, almost forgot.
Unmute me right now. Thank you. I did not appreciate that, and you almost forgot the coolest part. A few years ago, that windstorm changed color from blue to golden. Scientists aren't really sure why, and I know why. Remember that hit internet sensation about the black and blue dress?
You mean the white and gold dress?
Literally nobody sees white and gold. Anyways, that meme got to Saturn, and Saturn's PR people wanted in.
Ugh, I shouldn't have unmuted you for that, but yeah, Saturn's northern winds are subject to pretty wild weather phenomena. Another big one, a violent storm that covers the entire planet. That's right, every 30 years, Saturn is taken over by the Great White Spot. The last one happened in 2010, so Chase should be safe to fly into Saturn. He'll have to come back in 2040 to see the Great White Spot.
Rico, mark that in my calendar, please.
Now, Saturn's most distinct feature is its huge rings. They're over 280,000 kilometers across, but only 1 kilometer thick. To the naked eye, they're practically two-dimensional.
And I'm gonna fly right through them. Of course, I could fly around them, but come on, that's like going to Paris and not seeing the pyramids. You gotta do the touristy stuff.
These rings are made up of millions of particles of ice, debris, even the remnants of dead planets. Pretty tough to navigate.
You always doubt me, Peter.
Well, in my defense, you do die pretty often. These rings are named in order of discovery, which makes the order pretty confusing. Chase will fly through E ring and then G, F, A, B, C, D. E-ring is the furthest from Saturn, and its material is almost entirely provided by ice and water from Enceladus, a moon of this gas giant. Enceladus has a hidden ocean beneath its icy surface, and it's known for its geysers that shoot ice particles into space. These particles often get caught in Saturn's rings, making E-ring appear brighter and bigger.
And this moon is tiny. We're talking 7 times smaller than Earth's moon, but even small moons can have an enormous effect. See, Tiffany, size doesn't matter. Whoa. That is beautiful.
It's true. Saturn's F-ring is particularly stunning. It's thin and narrow, but it's also wild and unpredictable. It doesn't look as smooth as the other rings of Saturn. That's because it's mostly made of icy particles, and these particles are being pulled by Saturn's 2 moons, Prometheus and Pandora. These moons keep the ring together, but they also mess with it, creating twists, clumps, and even braids in the ring.
That was my favorite ring so far. All right, next up, A.
The A and B rings are the 2 brightest rings. They're separated by the Cassini division, which is the largest gap between any of Saturn's rings. The Cassini division is over 4,800 kilometers wide, and it's likely caused by Mimas, Saturn's smallest and closest moon. Mimas has a modest radius of 200 kilometers, and it doesn't even have a fully round shape.
Some distinguished scholars say that it was the inspiration for the Death Star.
No, you are saying that. Mimas was not the inspiration for the Death Star, as the first Star Wars, Episode 4, A New Hope, it came out 3 years before the Voyager spacecraft captured detailed images of Mimas. But even this little moon is enough to disturb the particles in Saturn's A-ring and nudge them out of their orbit with its gravitational pull, creating something as vast as the Cassini division. But enjoy this gap while you can. Mimas has begun to drift away from Saturn, and without it affecting Saturn's rings, in some 40 million years, the Cassini division will close.
You know, it's awesome that the balance of orbits and moons and gravitational pulls produces something as beautiful as Saturn's rings. It really makes me think about the way that we're all a web of interconnectivity, how even small things can have an unexpectedly huge impact in people's lives.
Wow, Chase, that's really profound.
It's like that time that Rico forgot to warn me about a crater on Pluto and I fell and broke my neck. One little f***ing robot, so much trouble. Anyways, I'm about to fly through C-Ring, and I gotta be mega careful because Titan, Saturn's biggest moon, creates these gravitational tsunamis.
It's true. Titan's gravity creates a 2-kilometer wall of ice particles that orbits around the ring. Scientists call them tsunamis, but they move pretty slow, so Chase will be fine.
All right, I made it through C. Just one more ring to go, and then I'll begin my descent into the atmosphere. Check it out, I got this sick space balloon that'll help me descend into the atmosphere. Caught it for half off from the returns bin. Pretty sick.
Now, the last time a spacecraft approached Saturn, well, it didn't end well for it. The Cassini spacecraft orbited this giant for over a decade. And finally, in 2017, scientists intentionally crashed it into the planet so that it wouldn't contaminate any potential habitable moons. They literally vaporized the entire ship. The debris might even be part of these rings now.
Wow, that's really poetic, like bodies returning to the soil. Of course, none of that's gonna happen with me. Me and my clearance balloon plan on surviving this one. I peg our chances at around 80%. Oh, is that a rip? Yeah, duct tape fixes that.
Saturn is mostly hydrogen and helium, which makes Saturn the only planet less dense than water. Yeah, if you threw it into a giant lake, it would float.
Rico, read the atmospheric composition.
Calculating. 75% hydrogen and 25% helium with traces of methane and water ice.
You needed a calculation for that? What are you doing with your free time?
To get all the way to the center of Saturn, you'd have to first go through the thick gaseous atmosphere, and then through a layer of liquid hydrogen, then through metallic hydrogen, and finally reach the incredibly rocky core. Now, you'd be passing through Saturn's troposphere, and it's freezing. The temperature here is about minus 175 degrees Celsius.
Yeah, I'm feeling the chills. Okay, let's go.
Yeah, you entered the atmosphere right around Saturn's equator, which is where the winds are the fastest. Not the best move. The gas planet rotates on its axis once every 10 hours and 33 minutes, which is incredibly fast for such a large planet. This speed means that Saturn actually bulges a little around its equator, like me, and concentrates jet streams in that area. Add so much heat rising from Saturn's interior, and you get high energy winds that reach up to 1,800 kilometers per hour. That's 4 times as fast as the fastest hurricane winds on Earth. You do not want to get caught in anything like that.
Rico, slow me down!
Calculating.
Calculating? What are you calculating?
Slow down initiated.
Oh, I'm gonna be sick. Oh god. Rico, next time we're about to enter a tormenting wind place, just slow us down to begin with.
Manual override needed to activate wind countering.
Ugh, you're about as helpful as usual. Oh god, what is that smell?
You're currently in Saturn's top cloud layer, 100 kilometers below the top of Saturn's troposphere. The clouds here are almost entirely ammonia and ammonia ice, which have a notoriously bad, pungent smell. And the temperature here is about minus 250 degrees Celsius. All this ammonia in Saturn's cloud tops is what gives Saturn its yellow hue.
You know, other than the horrible smell, the freezing temperature, and Rico's inability to use a calculator, this place isn't that bad. We moved away from the equator, so the wind's a little slower. The pressure is, Rico, give me a pressure reading.
400 millibars.
That's like 40% of Earth's pressure. Honestly, I'm chilling.
After the stinky ammonia clouds comes the second cloud deck, made of ammonium hydrosulfide clouds.
Rico, another pressure read.
1.7 bars.
Oh, okay, that's not that bad. That's like just a little bit more than Earth. All right, let's keep going down.
170 kilometers below the troposphere. Temperature reading, minus 70 degrees Celsius.
Oh god, it smells even worse here. Oh god. What is going on?
Ammonia hydrosulfide detected.
Oh great, great. My two favorite scent combos, together at last. Urine and fart. Chef's kiss.
At this depth, the pressure is about 5 bars. That's like scuba diving in a depth of about 35 meters. Not pleasant, but it's not unimaginably painful either.
Oh, my sinuses are starting to burn. If I just don't use my nose, I can get through this.
As the pressure and temperature steadily increase deeper into Saturn's atmosphere, more complex compounds form. The upper layers of Saturn only have ammonia ice, but as you go deeper, you'd be surrounded by ammonium hydrosulfide. Sadly for Chase, complex compounds don't always mean better smelling ones.
Yeah, I'm still waiting for Chanel number 5 to make a planet, but it's getting a little warmer in here, so soon it'll feel like a tropical vacation.
You are 220 kilometers below the troposphere. Temperature reading, 0 degrees Celsius. Pressure reading, 10 bars.
This is Saturn's thickest cloud layer. It spans 10 kilometers and is mostly made of water ice and some ammonium droplets.
What's happening?
High pressures causing balloon deflation.
Okay, so I guess when I came up with this balloon idea, I was thinking about descending into the planet. And I forgot to think about ascending. On the way back out. Yikes.
The cloud layers and outer atmosphere are just 17% of Saturn. The other 83% is almost entirely made up of liquid hydrogen, with a relatively small rocky core at the very center. This deep into Saturn's atmosphere, the pressure is extremely high, and it's constantly increasing. All this incredible pressure does one interesting thing. It turns hydrogen gas into a liquid. So just 500 kilometers below the troposphere, the pressure is 1,000 times higher than it is on Earth.
God, this is really unpleasant. It's hot and it hurts. It's hot, it's so hot, and it's a liquid, not a gas. It's hot and it's counterintuitive too.
That's just the power of 1,000 bars of pressure.
Rico, what is it, temperature? Rico, calculate temperature, please.
Calculating. 730 degrees Celsius.
Okay, and how's my balloon doing?
Heat and pressure accelerating balloon deflation.
Oh, that's not good. That's not good at all. That's not good for Chase Boy. Oh no.
17% inflation.
Oh man, if only real inflation rates would come down this quick, I could buy eggs again.
13% inflation.
Okay, you can stop now. Seriously, next time I'm installing a reinflate feature, or a go up feature, or a grappling hook. Something!
0% inflation.
Huh? Ah!
Well, Chase is currently falling through 60,000 kilometers of liquid hydrogen. As he goes deeper into Saturn, the pressure will become even more unbearable. Soon, it'll get as high as 2 megabars. That's 2 million times the pressure you experience on Earth. At this point, atoms are under so much pressure that they can't maintain their shape. The pressure literally squeezes the atoms so much that their electrons create an electrically conductive layer in the planet, metallic hydrogen. This layer is 30,000 kilometers thick and surrounds Saturn's rocky core. But let's see if Chase makes it that far.
Temperature reading, 5,700 degrees Celsius.
Oh, Rico, do not malfunction. If anything in this suit zaps, I'm gonna get fried. Oh, Rico, we found it. Oh, man. Oh, God. Okay, let's just read the composition and then get out of here, okay? The first people to see Saturn's core. This is awesome. Oh, Rico, come on. Help! Rico, just get the retract. Oh, that wasn't so bad. That was just.
Okay, this is the favorite, probably the biggest favorite of everybody on What If. So it goes a little bit back and forth between Jupiter and Saturn.
The golden giant.
But those two gas giants, I think Saturn mostly because of the rings, am I right? That's what makes everybody, it's sort of instantly recognizable.
Yeah,
More so than the Great Red Spot.
it's true.
And that's really cool.
It's the most unique. In fact, let's just dive right into those rings.
Okay, let's go in the
now.
rings.
Let's see what it's like.
Let's wait to not land on Saturn because it has no solid surface. Let's dive right into the rings. We could land on one of those things.
Let's just,
Those are chunks of ice and chunks of rock.
yeah, and they're various
Not the same at the same
sizes.
time. Some of them are rock and some of them are ice. And some of them are rock with ice.
Now imagine this is you. You're a probe. You have landed on a rock.
Okay. Oh, that's
on
cool. Yeah,
Saturn, And there's the sun. It's a lot smaller. It's pretty small right now, but
It seems to be getting smaller and smaller as we get further away from it.
yeah, that's yeah, that's how
Makes sense?
kind of how everything works.
Yeah.
Yeah.
Do we have an idea of what the diameter is? Yeah, I can see the diameter is 11 million kilometers. No, that's 116,000
116,000 kilometers.
in diameter.
Yes.
So that is, circumference is obviously going to be radius squared, and that will be, I can't do the math right now.
250,000.
Or pi r squared.
Oh, 3 pi.
It's pi r squared, radius, circumference.
Just like a 700, almost 800,000 or so.
Not gonna do the math, but just know
in my head.
at home how big it is. Oh, really? That's in your head?
Yeah, I don't know if that's right.
Wow. Well, then
We're not what if mathematics, not yet at least.
we only give facts, Stu.
Anyway, this is the beauty of
So these, like I said,
Saturn's rings.
let me just tell you a little bit more. They're mostly water molecule based. They're not necessarily as much rock as I may have said earlier. They're mostly water based, and some of them go. Some of them are very, very tiny. Some of the particles are like micron sizes, and some of them are as big as 10 meters, 30 feet wide.
It's like as big as a building. Some of them.
Yeah, 30 feet tall. That's like 4 stories.
Those are some big rocks.
It's not really forced. What is a story? Not only 6 feet. That would be ridiculous.
The story's not 6 feet, is it?
No, it's got to be at least 10 feet.
Yeah,
So 3 stories.
3 stories.
It's a 3-story building. So what else can we Can you tell me about the rings? That's since we dug right into them. The system is 282,000 kilometers wide.
Wow, that is a huge.
282,000 kilometers wide. But guess how thick they are?
Should we back out to really
Yeah,
see
back out and see.
how?
So that line, that black line, I think that we saw.
Look at that.
So that's 282 from not diameter, but from one side of the rings to the inner side of the rings, not all the way to the other side of the planet, but
That
just
is
one side of the rings.
absolutely massive.
But then turn it on its side and show me how wide or how not wide they are. Look at that, they almost disappear. You know why they almost disappear?
in fact, it has disappeared.
Yeah, they did disappear because we're so far away we can't see them. But if we were right up close, that ring system,
We're getting in there.
it's only 10 meters tall.
That's it.
That's 30 feet. That's 2 to 3 stories.
That's a story, right?
Yeah. Isn't that nuts that you could be that wide and only 10 meters thick?
Look at that. We can kind of, as we slowly descend through it, you can kind of see it, and we're done.
That's pretty cool.
And yet, if we were to go through it slowly,
Uh-huh.
it would take us.
Well, depending on how fast we're
hours,
driving.
days.
Wow, and look at this is like Star Wars.
Yeah, so right now we're going 100 meters per second.
This is more to the point. This is what Star Wars really is, when they go through the asteroid field.
Yeah.
Because in real life, asteroids are so far apart, you would never be dodging them like this. Here, inside Saturn's rings, you're dodging stuff. Thank you very much for.
Yeah, now we're playing.
Now this system, will this program let us hit anything ever?
No, so
Okay.
we're safe. We're just
Okay,
kind of
we're
going
good.
through it. In fact,
We're like Luke in the X-wing, or more like Han in the Millennium Falcon.
Yeah, because don't they go through? They go through something like that.
And is Chewie driving? No, Chewie's
Yeah, he's an
navigating.
expert. Look, and it's gone. It's there and it's gone.
That's great. The rings are beautiful, but what happens on
If we were
the
to
planet?
actually go on it. Let's look at this beautiful.
My guess is you can't land on it. It's a gas giant.
You are correct. This is the
It's not really a guess. I've done a
second-
lot of videos about Saturn.
This is the second planet. This is as close as we can get. It is a gaseous, if you will. Gaseous planet. We can't get much farther than this. If we were to turn off the atmosphere and clouds, you can see it's just like, these are the clouds. So we can't really turn them off, but
Okay.
So the best we can get, really, this is as close as we can get. If we were to look up, we can see the stars. You know, this is kind of like very high stratosphere if we were on Earth, as a good example. But this is about the best we can do. So unfortunately, we can only do so much when getting close.
And we cannot land on,
We cannot land.
which is, I think, is what you basically
Saturn.
just been saying.
That was my long-winded way to
Yeah,
say it.
yeah. So I'm the condenser here.
It's great.
But one thing to notice too is that, well, I don't think you would notice it, but one fact that I have kicking around in my head is Saturn floats. Saturn floats. If you could find an ocean big enough to set Saturn down in it, it floats.
Yeah. Isn't that amazing? Isn't that what?
Not because it's full of, it's not because it's a balloon full of air, but it is gas.
Yep.
It's lighter than water.
Yeah, it's very. Let's see.
Water's denser. It's just simple physics, people.
Tell me what you think about this. Let's back up a bit and tell me what you think about this sunrise.
Sunrise.
Yeah, you're on a nice little probe. You're waiting. You see the beautiful rings. The sun has hit
That's
the
cool.
rings before, and
Yeah.
now
Red.
the sun rises as it hits the planet. You're seeing these different gases in the atmosphere affecting this. If we were down in the clouds, you wouldn't be able to see the sun at all, but you'd be able to see that light also being refracted in different ways.
I like it.
It's gorgeous.
It looks very futuristic to me. That I'm like, I don't know, this ring system here kind of looks like I don't know, a big like sky highway.
Yeah.
Or something that people are driving through. And then, you know, when I can see the gaseous atmosphere. And then as the sun rises, we obviously have that deep red.
Yeah.
And then it's changing to orange, and then I'm getting green, which would kind of make me sick if I'm looking up and the sky's kind of turning green. I'm like, that's some disgusting poisonous gas.
Yeah.
But then it gets up here, and this just looks like an animation almost.
looks
It is an
gorgeous.
animation, but it looks like an animated
A beautiful
movie about space.
render, and as it comes down, we're seeing the sun come down. I'll slow it down right around here.
And we go from the blues into the greens to the yellows to the orange, likely.
What I love is that yellow and that red hitting the
Yeah.
sun, and then it's
You know why? Because it reminds you of Earth.
yeah.
What you like is sunrises on Earth, sunsets on Earth.
This is what I really like, is that it's completely dark here, and you look, and the rings, because obviously the rings are much
That's
higher up. So like
Pretty
if we were
cool.
in this spot, obviously if we were directly below the rings, you wouldn't be able to see much because it's very thin. But because we're at this perfect angle, even though the sun has set, you kind of get this like beautiful reflection.
And is it staying like that all night?
It'll stay like that for a good amount of time, if not the entire night.
Okay.
Let's see if it goes down throughout the whole night. We'll wait over here. There's a little bit. There's that shadow. That is Saturn. You see that? That kind of shadow. That's us.
Okay. We are Saturn.
We are all of Saturn, and then
That's
as it
cool.
comes back up. So you wouldn't really have any time to not have light kind of around. So you'd save on energy bills. That's pretty good, I'd say.
Right. You could have solar, but you're living in the clouds.
You are.
So there. What are you going to rate this planet?
Me personally,
Actually, I'll go first.
I feel like I'd like to hear your first.
Yeah,
Roshan.
I thought you would. I'll give it a 6. It's kind of fun to be a 6 because of the various different colors. I like the facts that I spit out about the rings and how great fun it was to drive through, like the Millennium Falcon. Yeah, not so bad. The bad things are you got to live in the clouds or live above the clouds. You can't touch the surface.
Couldn't even really live on.
But it's
Saturn.
big and it's cool, and everybody wants something to do with Saturn. So, what did I say? 5?
Six.
It's 6.
Yeah.
Yep.
I'll give it 6 as well. I think this is the best you can get without actually living on the planet.
Okay.
You got beautiful rings. And I know as a part of you thinking that I'm just copying you. I'm not copying you, Peter. And we're gonna do a quick thing where this is Titan.
Yeah, Titan is one of the moons of
Gorgeous.
Saturn.
I'd much rather prefer to live on Titan, mostly because I can.
Really?
Yeah, it's
Okay.
gorgeous. You can kind of see this beautiful sunrise and sunset on this. We'll kind of wait around, but what I love is I just love seeing Saturn here. Let me see if I can do a little bit of there's that magnification. Just being able to see your giant home planet.
Yeah, well, I'm guessing Titan would be your home planet, but what's really cool from the surface of Titan is watching those other moons circle around.
And you could probably almost see the rings as well. In higher definition.
You should,
you're able to see it, but it's
we
a
should
little
really
bit
get a
tougher.
high definition machine here. You don't need to rate it, but what we should notice is that there's lakes on Titan.
Yeah, so
And I know this because we've done some what ifs about Titan's lakes. Could you swim in the lakes of Titan? No.
don't.
The answer is no.
Let's not do that. Yeah, so this is, again, it's a huge planet. What I love is this atmosphere kind of spinning around.
Very nitrogen-rich planet, this one. Not certainly not planet, it's a moon. Duh.
But yeah, it's a lot harder to see the lakes on here. Unfortunately, we won't be able to.
Well,
let's try to turn off those clouds. Look at that. There we go.
Those are the lakes?
Those are the lakes. Isn't that gorgeous?
yeah.
It's kind of you kind of realize how much clouds affects vision.
Yeah.
You know, but look at that, gorgeous. Look at this huge.
Look at that one. If you stop it there and turn it a little bit counterclockwise. Can you? Okay, you can't.
Well, I can let it play out so it can turn itself.
No, so I'm thinking, look at this. It's a person there. It's like a little.
Oh, you mean like
Yeah,
that?
there you go. Look
It's
at
a
that.
face, it's an
Yeah.
eye, it's like a little
It's
monster.
like a
man.
little monster man flying through. Wow, did I just discover something?
Oh, like
Do I get to name it?
the Peter face.
Yeah.
That's what we call it.
Lake Peter.
Lake Peter.
This is Lake Peter on Titan. Take note.
If this is how you picture walking on Uranus, you're wrong. Let's start this again. Are you ready to take a trip to the outer regions of the solar system? To explore the weirdest planet in our cosmic neighborhood? To venture down into a place that's never been studied up close by any spacecraft? Buckle up for an icy, violent, and stinky adventure because your mission is to spend 5 seconds on Uranus and come back. If you can. Traveling to Uranus would be a long, strange journey. First, you'd have to spend 10 long years in a spaceship, speeding toward the outskirts of the solar system. If you're lucky, you might even pass Jupiter and Saturn on the way. Just make sure you pack enough food and fuel. Well, there are some things you should know about this world. Uranus isn't a rocky planet like Earth. It's an ice giant like Neptune, and it's the only planet in the solar system that spins on its side. It spins fast, too. One day on Uranus is just 17 Earth hours. Of course, you wouldn't last that long on it. Not a chance. Once you arrived at your destination, you'd still have some work to do to get close to this giant blue planet. You might have to dodge Uranian rings. Yeah, Uranus has rings. 13 of them. They aren't big and majestic like the gorgeous rings of Saturn. The outer rings are bright and easy to spot, but the inner rings are narrow and dark. You'd have to navigate this part of the trip with the utmost care. As you made your way through the dusty rings of Uranus, you'd see its glorious blue atmosphere up close for the first time in human history. Take a moment to enjoy the
Uranus. What an oddballs planet. You know, I flew by it a month ago. That was fun. You wanna know why nobody, and I mean nobody, has ever tried to land anything on the surface of this beautiful planet? Because Uranus has no surface. It's just a swirling ball of toxic gas compressed around a small, icy core. Oh, and wait till I tell you why those gases on Uranus are toxic. Yeah. Gross.
Yeah, okay, thanks for your input, Chase. It's true, Uranus might have a calming blue color, but it's cold and toxic. Not the kind of blue planet you want to visit.
That's okay. I think you should sit this one out. Here I go! Woohoo! It's brisk here. Oh, Rico, what's the temperature?
Minus 224 degrees Celsius.
Oh, that's cold. That explains why I can't feel my fingers, or my toes, or the rest of my body. Okay, well, at least those 5 seconds are done. Okay, Rico, it's time to go home. Let's bounce.
Impossible. If my calculations are correct, you will reach the icy core in 54.4 minutes.
So? What? That wasn't the plan. And what's 0.4 of a minute? Use seconds, you dumb bot!
I suggest you take this opportunity to study the planet up close and report back.
Well, I suggest you take this opportunity and stuff it up your charging port!
I don't have a charging port.
No one cares, Rico! No one cares! Honestly, this sucks. Uranus smells like
Yeah, the reason Uranus smells so bad is that the clouds in its upper atmosphere are partially made up of hydrogen sulfide. Not only does this make the planet stink, but it's also pretty toxic. Whatever you do, do not inhale it. If you did, it'd make you faint and die instantly.
What? It would have been real nice to know this before I jumped.
Yeah, well, after falling through the stinky clouds at the top atmosphere, you'd find yourself in the mix of 82% hydrogen, 15% helium, and a bit of methane. Methane gas is what gives Uranus that bluish-green haze because it absorbs light at the red end of the spectrum.
Huh. These clouds are getting a little weird. Kind of floaty.
Yeah, the atmosphere on Uranus is very dense. After passing through its top layer, you'd stop falling and start swimming in it instead. As you were paddling deeper, you'd start getting pelted by frozen gas crystals. But at least the temperature would be rising.
I don't know about that. I don't feel warm at all. Rico, give me the stats.
The temperature around you has indeed gone up to minus 208 degrees Celsius. My calculations show you can expect minus 153 degrees Celsius in the lower atmosphere.
Cool. Great. Ow! What is that?
That? Well, that's diamond rain. Yeah, on Uranus, it rains diamonds. That's because the Uranian atmosphere is rich in methane, a single carbon compound. Under extreme pressure, the methane molecules break apart and crystallize into diamonds. But the worst part is the wind. You'd be dealing with winds gusting at speeds of up to 900 kilometers per hour. That's 3.5 times stronger than a Category 5 hurricane here on Earth.
Rico, it's getting tight in here. Oh, I can hardly breathe. And when I do breathe, it smells like ass.
Of course. The pressure is 100 times greater than the atmospheric pressure at Earth's sea level. You are approaching the mantle.
The good news is you wouldn't splatter on anything because there's not much in the way of solids on Uranus. The Uranian mantle is made of water, ammonia, and methane ice. It would be pitch black in here, and thanks to the extreme gravity, you wouldn't be able to move a muscle. And it would still be incredibly cold. What you should be worried about is the immense pressure that would be rapidly increasing the closer you got to the planet's center. It would squish you before you ever got to the core.
Being crushed by Uranus. I always thought it would be way nicer. God.
Well, in this extreme pressure environment, your carbon-based body could turn into diamonds and drop down into the core. What a spectacular way to finish this one-way trip to the center of Uranus. Chase? Oh, right.
Okay, so our very first ice giant,
Yeah.
and you pronounce it.
Uranus, it's funny. I can't help it.
It is funnier when we say that, but realistically, as we know, as astronomers, which we are not, we call it Uranus.
Yeah.
Because saying urine is much more funny than saying anus. Oh, I'm seeing rings.
Yeah, this is the surprise. So I'm going to give you a cool, dramatic, cinematic angle for you to really see those rings. So we're not going to be able to see into it like Saturn, but we can really, you can really see them reflecting off. They're a lot thinner than Saturn's, and you can really see that it's actually pretty large as the sun kind of goes through it.
Yeah.
And and it's pretty hard to see because if we click on Uranus and go to look on it, it's without seeing the sun, it's very difficult to see. We see it for a brief moment there, but you can see it wrapping around.
Yeah, it's like wire, piano wire or something like that. But I'm sure if we dug deep into it, we're going to see ice.
So this is Uranus. It's gorgeous. It's cold.
Kind of gorgeous. One color. Well, kind of like, not one color, but like various shades of blue.
It's kind of like a blue freezy. That was like during the summer.
Here's the thing. Blue, frozen, ice.
It's true.
Right? It's a cold, icy atmosphere for sure. And it's a planet of extremes. It goes through, extreme, obviously it's extremely cold. It goes through seasons of daylight and darkness, like decades of sunlight, decades of darkness. So, and one of the reasons of that is because it doesn't rotate on its axis like this. It's actually tilted 98-degree angle, so just over 90, and it rolls. It's like a ball rolling away from you. So instead of like a Harlem Globetrotters spinning basketball on your finger, it's more like a bowling ball rolling.
We can kind of see this here.
Yeah.
As we speed it up, there's the sun over there. As you can see, as we're rotating, the sun is barely moving on that planet because it takes a very long time to orbit the sun.
Right.
You're talking about that decade right here, 84 years.
84 years to go around the sun.
Just once. It's a lifetime right there.
Yeah, I'm lucky if I make it to 84, to be honest. And I'm usually honest. And the blue color is there's gas as well as the ice. We've got methane gas there, and that sort of is what is coloring, tinting the atmosphere.
That's that big
blue.
contribution
Yeah.
to it. Yeah.
And it's interesting that, of course, when you rotate like that, your North Pole will be facing the sun, or South Pole will be facing the sun.
Yeah.
But those poles actually switch. They take turns. They don't switch like the North Pole becomes the South Pole, but the South Pole starts looking at the sun for decades, and then eventually the North Pole ends up looking at the sun.
Yeah.
So that's why I was talking about periods of darkness and sunlight.
Well, when it takes that long to do an orbital period, you're just gonna, this side of Uranus, caught in dark, you're just stuck there for a long time. And luckily there's no life on Uranus.
Not that we know of, Stu. Please. We haven't really visited it, so we don't know. The closest we've come, Voyager 2, was there in 1996. And so far has been the only spacecraft to do a flyby. Okay, so we're down on the surface of Uranus?
Yes, this is where...
Can you land a probe on Uranus?
No, we cannot.
Oh, no?
There's only one way to check it. That's for What If After Dark. This is about as far as we can go. As you can see, I'm trying to go downwards. It won't let me. This is the cloud bay.
Okay.
So... this is why it's so easy to see space, so easy to see the atmosphere and all that kind of stuff. I take that out. This is about as close as we can get, but we are in that atmosphere, which is what we're seeing, those beautiful, absolutely beautiful colors, and also a very interesting sunrise and sunset because of the tilt of the axis of of Uranus. So we're gonna start to see that as we kind of let it play out. So,
And this is the coldest planet. You would think Neptune because Neptune's further away, but Uranus is actually colder than Neptune.
it's true. It's very true.
Yeah, thank you very much. Glad you agree. And it doesn't feel like violently cold though, apparently, and nobody's actually ever been there, so how can we comment on that? But everything is so profoundly still that you don't really feel the winds or the cold.
No.
I can't imagine you don't feel minus 224 degrees Celsius.
I wouldn't feel it for long. You know? So what's really interesting here is this 84-year cycle kind of coming in here, right? So when we think of a sunrise, sunset, we think it's just gonna rotate around, but because it takes such a long time to kind of go around, and also being on its axis, instead we're kind of getting like a swirling, kind of like a toilet bowl idea, where if we speed it up, we kind of see that it's just kind of spinning in circles, and it comes down and it gets close to setting, and then it just kind of teases you, gets close.
It's an erratic.
Slowly it rises, and as we keep going, it's gonna get lower and lower and lower, and we're spinning out of control. And obviously, this we're doing 16-hour days, but it takes 17-hour days, but it takes 84 years to do orbital period. So it could be.
So I'm looking at this for 84 years. Oh, sorry, for decades.
For decades. It could be decades before you see an actual sunset.
You mentioned the swirling around the toilet. This is the North American or the Northern Hemisphere toilet.
Yeah.
Because it's going clockwise.
Yeah, exactly.
And then I guess if the moon was on, or the sun was on the other side of the planet, which will never happen, we would see it going the other way.
Exactly.
But that's for another.
But anyway, we don't want to make the audience
dizzy and disgusted.
Dizzy and all over the place, but looking at this.
So Uranus is swirling around the toilet.
Yeah. And so it doesn't,
Uranus swirling around the toilet?
We're actually seeing.
Did you get the joke? Uranus swirling around the toilet.
I just didn't think it was that funny. I didn't want to call it out. I thought I'd just go by it, but you kind of just, You can leave a message if you thought it was funny. Chat, was it funny? You let me know.
Was it funny? It's not. But at least I know when things aren't funny. And at least I keep pushing the joke until somebody says something. Damn it.
Someone has to laugh. Also, what's interesting here is that we're actually going in the opposite direction, where it's actually getting higher up because of just how long it takes to go through this. So instead of it dipping, it's going to go higher up, and then it's going to dip later. Because you can kind of noticing that it's not dipping too far. It's dipping a little bit close, but not.
Is it going to look like that for 84 years?
No, it won't look like this for 84
Sometimes
years.
It'll dip below this.
Yes, yeah. So that's that swirling toilet thing that I was talking about, where it kind of it's this, and it's slowly just kind of changing over time. So maybe it's
You were talking, I wasn't paying attention.
That's how you know this is a good team right here. You tell bad jokes, I talk fast, and you don't listen.
That's what I do.
That's how What If works. What are you feeling? What's your baseline? It's unique. That's something nice, right?
Yeah. Okay. So here's what it's got going for it. Cool colors, no doubt.
Gorgeous.
Tiny little sun. Not so excited about the sunset, other than the colors are cool. And like we say, there is no sunset because it doesn't actually dip below the horizon.
Well, if it would take.
But that
decades.
sort of swirling toilet effect is cool.
Yeah.
It's not anything that you see anywhere else, and that's pretty darn cool. Also, the fact that it's got the rings, bonus points. We didn't mention the 28 moons, but that's a thing too. Cold, and you don't really want to hang out on the surface. You couldn't live there, but I don't know. It's got some neat things going for it. How about 4 out of 10?
4 out of 10. Wow. I would go 2 out of 10. You know what?
You're the one who sold me. You just sold me on this uniqueness. So I upped my rating, and now you're going 2.
I'm a good salesman.
You're baiting and switching.
This isn't a sunset. I'm mad at that. You're telling me you have to go for years with no sunset? That's awful. That sounds awful. Especially when it gets close.
It's like a sun cycle,
Yeah.
which is cool. It's interesting.
It's new, but new isn't always good.
I'm not gonna fight you on this, but it's a 4. Okay, let's move on.
This is Neptune, the windiest, most brutal planet you'll see in the solar system. No average person would ever want to visit it.
Well, thank you. I would describe myself as above average. What up, Chaseheads? It's your boy, Chase. Today, I'm taking a deep dive to the darkest depths of Neptune. I'm going all the way to its dirty core. I'll show you some crazy, violent winds, and you'll see why Neptune can make you stinking rich. Rico, initiate orbital insertion.
Affirmative.
Neptune is gigantic, almost as large as Uranus.
Neptune is the closest planet to the Sun and is blue due to the presence of water.
Yeah, and what? No. Wait, there was no part of that sentence that was not completely wrong. Well, looks like Rico's on the fritz. Not to worry though, once I get deeper into Neptune, I'll be able to collect some valuable materials to upgrade Rico's quantum computer.
Neptune is a massive ice giant. Just like Uranus, it's blue and it doesn't have any solid surface for you to stand on. This icy planet is cold and extremely dark. It's 30 times further away from the sun than Earth is, and that's why it receives only a small amount of sunlight.
Now I know you see this nice and bright, but that's because video editors are color correcting this. In reality, it looks like garbage. See? Before, after, before, after. Much better. So the problem is that Neptune has an irregular and massive magnetic field, and that's messing with Rico. It's making him toast.
Water.
And insane. It also fried my ship's computers, so looks like I'm gonna have to dive in from here.
If you're planning to reach the core of Neptune, you're gonna have to battle through extreme wind, ice and crystal rain, and a molten mantle.
Neptune's thermosphere.
So, Rico's being a little bit less helpful than usual, but I can tell you that it feels chilly. Like exactly what you'd expect from an ice giant. And by the way, an ice giant isn't a planet literally covered in solid ice. It's like a gas giant, but instead of just gas, it's more like a slushy.
Neptune is incredibly cold. At this point, you'd experience temperatures of minus 240 degrees Celsius.
Yeah, that sounds about right.
Neptune and Uranus share a lot in common. Similar to Uranus, Neptune's heat signature shows us that the planet is creating a lot of heat well below its clouds.
Great, so add scorching temperatures to the list. You know, I'm actually looking forward to a bit of warmth because it's so cold.
Now, the deeper into Neptune you go, the more intense the conditions would get. And you wouldn't be able to breathe in this atmosphere.
Now, most people don't know this, but the bluish color of Neptune is because of its composition, made up of hydrogen, helium, and methane. Yeah, fart planet! It's getting a little hot for my liking, Rico. Rico! God, right, I keep forgetting that. I rely on this robot way too much. I'm somewhere in the middle of the atmosphere. I just passed clouds of water, hydrogen sulfide, ammonia, and now I feel like I'm in an oven. This doesn't make any sense. Neptune is supposed to be one of the coldest planets in this solar system. Feels like I'm on Venus here.
Just like Earth's atmosphere, Neptune's atmosphere has layers. At this point, you've passed through the exosphere and have entered the thermosphere. And the temperature here reaches 477 degrees Celsius. Scientists don't know exactly why Neptune's thermosphere has this boiling heat at this depth. It could be gravity waves from the planet's interior, or an atmospheric interaction with Neptune's magnetic field. Either way, things are going to be toasty.
Wow, it's hot. Okay, Rico, it's time. Initiate cooling.
Initiating stabilizers.
Oh, God. Okay, well, I'm sure that'll be useful eventually. Whoa! This is almost the greatest day ever! I'm skydiving in the Aurora Borealis. It's scorching hot, but there's hardly any wind. And it looks amazing!
The Aurora Borealis only happens on Earth, but the same process can happen on Neptune in the thermosphere, where the concentration of charged particles...
Yada. Guys, I was just in Neptune's planetary fireworks. My life is awesome. This mission is gonna be a breeze.
Detecting breeze.
Initiate those stabilizers anytime, Rico.
At this depth, the atmosphere is extremely windy. Winds here can reach speeds of up to 2,100 kilometers per hour. And the temperature drops to about minus 190 degrees Celsius.
Hey guys, I made it to about halfway through Neptune, and it's pretty chill. It's chilly, actually. It's quite cold. But being honest, I'm not quite as excited about the fart planet as I once was. It really sounded a lot cooler on paper. This planet is toxic! Literally, it is made up of toxic gases that I am smelling way too much of. The upper layers of this fart marble have methane, but now it's getting clouds of ammonia, and they're getting denser. Soon, I'll be swimming in fart. Rico, I swear to space, turn on the gas filtration, please!
Gas filtration.
Huh?
Offline.
Oh my god, I'm gonna barf. It's like a can of bleach exploded in my face with a 5-week-old carton of eggs. Okay, I'm just gonna hold my breath all the way to the core. Oh god, that's so much worse. Bad idea, bailing out. What is this? I feel like the weight of this entire blue planet is sitting on my shoulders.
That's because it is. Neptune is incredibly heavy. It's the 4th largest and the 3rd most massive planet in the solar system. As you descend deeper into its center, the immense weight of the atmosphere above you would be crushing.
Yeah, okay, yes, I can feel that.
Gas filtration online.
Oh, for space sake, thank you, Rico! Oh, yeah, that's the good stuff. Now, I'm sure you're wondering the reason why I'm plummeting through all these farts, temperature changes, and windy storms. What's so special about the center of this cosmic crop duster? I'll tell you. Diamonds. And no, not because I want to get rich, although that would be nice. I do have a lot of burger debt. I need those because I can use them to fix Rico's quantum computer. Oh look, I'm almost there. Diamonds? I must be in the mantle by now.
Approaching the mantle.
Yeah, thank you, boss. Just like I expected, diamond rain. Now I just need to collect a few of these. Oh, the pressure. It's killing me.
As you dive deeper into the mantle, the pressure and heat will grow rapidly. At this point, the pressure is 50,000 times higher than on Earth. And the temperature is about to reach 3,700 degrees Celsius.
I was gonna say, it sure feels like a million elephants are standing on my back, and my chest, and my face. It's so weird here.
The mantle is made up of a mixture of water, ammonia, and methane in a supercritical state. That means it's somewhere between gas and liquid.
What up, guys? Who's in a superfluid, superconducting magnetosphere? This guy. That's right. So you're probably like, whatever you're doing can't be worth all this, right, Chase? Totally wrong! Worth it? At these pressures on Neptune, methane diamonds rain, baby! But there should be even bigger ones closer to the core. And as a service to you guys, I'm gonna go check it out. Let's do this. Tough to breathe, move, burning, just a little further. There, a perfect methane diamond.
The core of Neptune is made up of rock and ice, and it's roughly the size of Earth.
So there's basically an Earth at the center of Neptune. Cool. Can't breathe. Rico, restart and install firmware upgrade labeled "Stop being such a friggin' pain, Rico _final-v6.exe. Do it.
Restart complete. Firmware and hardware upgrade complete. Ship link reestablished.
Yes! Yes! Now you're online! I'm dying, Rico! Get me out of here, baby!
With your current equipment, your survival probability is 0%.
Just 0? That's it? Not like 0.1 or something?
Suit degradation imminent. Survival probability 0.0000000.
Alright, Chase-heads. It's not looking good for me. I don't think I'm gonna make it out, but this time, I'm gonna choose how I go. And I choose to take this helmet off and die by toxic planet fart superfluids. It'll preserve my body in this epic looking pose. And it'll...
Okay, off to Neptune.
This is it. This is Neptune itself.
Neptune's another ice giant. Is that why it's blue?
That is correct.
Blue ice? Why do we associate ice and blue?
I
don't know.
That's the color.
I guess that's maybe how light reflects
That's
through ice. Yeah. So Uranus is the other ice planet, and as we talked about already, Saturn and Jupiter, the gas giants. Of the giants, this one is the densest. Whoa.
Yeah, this is.
What am I looking at here?
This is the a render and not actual real life of.
This is not real life, kids. This is a rendering. This is not a shot that Chase Dies in Space just pulled out of Neptune. But this is in our solar system, and it is rings. Most people don't know
Neptune has
that
rings.
Neptune also has rings.
Yeah, so if we back out a little bit, we can kind of see what it's like. So as we rise, you get those Saturn vibes. But as we keep going higher, you notice the rings kind of disappear. And in fact, if we take that far view away, rings are almost completely gone.
It's like it's an optical
You
illusion.
can kind of see them down here.
It's a trick by a birthday magician.
But this is what it would be like if we were actually in Neptune's orbit in the rings. And as you can see, there's various sizes of ice chunks.
Yeah, that looks pretty scary.
All around.
Although they are probably fairly far apart from each other.
That is correct, yeah.
It's interesting because most people don't realize what rings are. I think growing up, I always thought they were like just lengths of gas or something like that. But really, they're chunks of rock or ice, and they're stuck in this orbit together. And you know, from up close, this is what they look like. But like we saw when you take an overhead look,
Can't really see them at all.
and no, you can't see them at all. Or you see them from above, from bird's eye view, you would see them as, yeah.
A single, suddenly all the rocks have disappeared. You can we see them here because the exposure is increased.
Yeah.
So we can see them out, but then when we actually see it as compared to the sun hitting Neptune here, almost completely gone. And then if we keep going,
Wow. And he puts his glasses back on.
it disappears.
Now, wind is a problem here on Neptune.
Yes, it's very, very windy.
Not just the velocity of the ice chunks orbiting it, but also down on the surface of this ice giant. The winds are traveling 2,000 kilometers per hour.
This is what we would see. This is what we would see here. See, these are little representations. This is a high definition image of Neptune.
This is not an actual picture?
This is not an actual picture, but it's a very high definition render of what Neptune would be like. And you're starting to notice that there's these storms. Tell me what this reminds you of.
It looks like the big red spot.
Exactly.
But it's not the big red spot. Is it the big black spot?
I believe it's the big blue spot.
The big blue spot. Okay.
I believe Neptune has had its own type of stormy thing, but it just hasn't lasted as long as Jupiter's Great Red Spot.
In fact, I think it was called the Great Dark Spot, and it has since disappeared. So we're looking at a historical.
Well, this is actually other storms appear. So we will see other great dark spots appear kind of over time. And so this is what this is. This is what down here, another spot. And they just appear and disappear more rapidly, right? There's another spot there. Think of a storm on Earth. Obviously, it's not going to last over 150 years like Jupiter. It's going to last a lot shorter. And on Neptune, it's a lot shorter of a time. But these spots are still appearing all over the planet.
Wow. And this just in, the blue color is because of the methane. So even though it's an ice giant, there's still gas clouds upon it, and the gas clouds make it, the gas surrounding it makes it blue.
Should we jump on the planet and see this?
Yeah, let's go down and have a peek.
Now again, we can't land on the planet.
No, because it's so windy?
Well, also there's nothing really there for us to land on. So what Space Sim has done, just a reminder, is that it has gone as close as we can without getting sucked in. So what we're seeing here, if we were to look down, is not directly land, but it's just gaseous cloud that's as far as we can go. So what we're seeing here is this. Here, I'll back up a little bit. We're seeing this absolutely beautiful sunrise. Let's back up a little bit. So we're seeing this beautiful sunrise, and what I love is the color that kind of comes from there.
Yeah.
As it's
like
slowly
what is that,
comes
like a
out.
magenta?
Yeah, I would say so. Almost like a
Pinkish something, right?
Yeah, and then hitting that red, and it's turning to that orange.
You're right, that is kind of cool colors.
It's absolutely gorgeous. If you could stand on Neptune, probably one of my favorite sunrises and sunsets. I would say so, yeah.
I don't like how small it is.
The sun?
Yeah.
It's kind of freaking me out a little bit.
Yeah.
So
Well, not freaking me out. I just like, it's not much of a sunset with this little piddly little sun going up and down.
That's true. We can get a telescope and make it look a little bit better if we want.
And so 16 hours, that is, what would you say, for 2/3 the length of an Earth day.
So then sunrise and sunset would be what, around 6 minutes or so? 6.66 minutes?
Yeah, I would say, 6, because we're thinking like a sunrise is usually 20 minutes-ish, a half hour.
You know what's really cool is you can notice here, that line.
You're pointing at that line,
Yeah, that's the ring. And we're kind of noticing.
Oh, the ring, yeah.
Yeah.
The ring, which is a series of rings.
Yeah, but we're seeing like that big. And what's really cool, as it goes over us.
Cool. That's really cool when the sunrise or sunset intersects The ring system.
The ring system. And as it slowly comes down, I mean, look at that. That's just gorgeous color. That's a screensaver.
Yeah, well,
right there.
we should make screensavers for the viewers at home. Leave your comments if you want us to make screensavers for you.
Yeah.
We don't know how to make screensavers, but if you want that, just let us know.
Yeah.
We'll tell somebody else around here.
All right, let's. As we jump to Triton, how are you feeling on a scale of 1 to 10 for Neptune, especially compared to our previous planets?
On a scale of 1 to 10, well, we haven't really. Well, we couldn't experience that's a problem then. So that factors into what I don't like about Neptune. You can't stand on it.
Yeah.
Too windy. I can't hear anything when the wind is going 2,000 kilometers an hour.
That's also a very good point. If we go back, we had the clouds turned off.
Yeah, turn my clouds on.
We turn the clouds on. You know what? The clouds aren't going to do too much because, again, we can't go that far down.
Right, so
because
forget
what's
the clouds.
directly below us, those are clouds. So
Are we going to forget the clouds or are we going to put the clouds on?
Well, the clouds are below us because we can't go any deeper.
Right. We're above the clouds, obviously.
We're above.
Let's talk about the actual planet Neptune.
Yeah.
2 out of 10.
2 out of 10. I'm surprised.
Here's the thing. Piddly sunset.
Piddly.
Windy, 2,000 kilometers an hour. I can't hear anything when the wind is like 50 kilometers an hour. So imagine being on there. Cold as all get out. And did I mention I can't stand on the surface?
That's true.
So the rings, interesting to have rings, but you're only going to see them. I don't know when you're going to see them.
We'll see a little bit here.
Like, would anybody on the planet see them all the time?
No, those clouds would be too much.
Right, so you're not going to see them. So unless you're out in space, with big whoop, I can just see the rings on a telescope somewhere.
It's true.
So instead of 0, I'll give you 2 just because some cool colors in your sunset.
I give it a 3 because I really enjoy the colors.
You did enjoy the colors.
And I like that ring a lot.
3 for colors?
Yeah, because like look at, we speed up. Look at that. It's gorgeous. Look at that, the sun hitting there. Beautiful.
You know we have that.
I like I'm a sucker for color.
There's other planets in the solar system with sunsets as well. This, however, is cool. This could be a screensaver. Write to us if you want screensavers. Even just like you could take a static shot of this right now. Hold up, pause.
Let me turn off.
Screenshot. Did you get it?
Wait, no,
okay.
Okay, wait there.
Okay, we cleared it off for you. Take a screenshot. Screensaver. Bang. Let's go.
Look at that, gorgeous.
That looks like.
This is what we have clouds on. Really interesting.
This looks like a Pink Floyd album.
Could be. Maybe this is the new Pink Floyd album.
Album cover.
Dark Side of Triton.
Well, this is the bright side of Triton. Look on the bright side of Triton.
What's really interesting
the dark side of Triton
is as we turn off the atmosphere, you can really see how that atmosphere affects.
Right. So you turned off the atmosphere.
Yeah. This is what
Can
it would
you
be like.
turn on the rainbow and the prism, and we'll have a real Dark Side of the Moon album cover here.
You want to throw that? How many screensavers are we making here, Peter?
Screensaver alert. Bang. Got it.
Take a picture right now.
Yeah.
You can Photoshop the triangle. Yeah, the surface of Triton is cold, cold, cold.
Yeah, I would imagine because
surprisingly, actually not surprisingly.
you're far out in space, far away from the sun.
Yep.
You have no atmosphere.
In fact, it's actually very similar to an upcoming planet. Not planet anymore, Pluto. It's very similar.
I was just about to guess Pluto actually, Stu. So you ruined it. Cool. Are we gonna rank this one? I guess not. It's just a moon. Forget
Triton,
it.
we don't need to rank it. It looks great.
It's a nice color though.
What up, guys? You asked and I delivered. I'm here on Pluto, and I'm gonna give you 3 reasons why Pluto is a planet, baby. Why? Because someone's gotta stick up for this little guy. Look at him, he's so cute.
Analyzing conditions. Atmosphere, nitrogen, traces of methane, and carbon monoxide. Current temperature, minus 232 degrees Celsius.
Yeah, oof, that's chilly. Well, that makes sense. Pluto is 6 billion kilometers away from the sun. So what makes a planet a planet? It's literally just 3 things. The first condition is that it has to orbit a star. Check please. The sun is barely visible from here, but it's there, and Pluto orbits it, so Pluto 1, haters 0.
Distance to the Sun, 5,867,639,023 kilometers.
Exactly. It's like 0.1% the brightness here that you've got over there on Earth. It's really dark, right? Hey, I think I see some mountains over there. Gotta check them out. Rico, remember that time we watched Mean Girls?
Negative.
You know, it got me thinking about, like, every time I've been bullied or rejected by all those alien hotties I ask out. I mean, that's not important. And no one has been more bullied than Pluto. For like 80 years it was considered a planet. And then, like, out of nowhere, it becomes a dwarf planet? Like, what's up with that? Thanks, Neil deGrasse Tyson.
Pluto was disqualified as a planet due to the discovery of large objects around its orbit.
Who didn't they punish back then? First Lindsay Lohan, then Britney Spears, then Pluto loses its status. Man, the 2000s were cruel. Yeah. This is definitely a mountain, and that's something a planet would have.
The presence of landscape elevation is not part of the planet definition specified by the International Astronomical Union.
But I mean, like, alright, but what if the mountains have water ice? I mean, look at this stuff. That is ice!
Many non-planetary bodies feature these landscape traits.
Right, yeah. I mean, I knew that from my various trips to moons and the suches. Alright, I tried to score some points for Pluto here, but Rico is being real annoying with his International Astronomical Union or whatever. But he's right. There are technically 3 criteria for a planet to be a planet. And number 2 is that it needs enough mass and gravity to form into a sphere. Some asteroids out there have wild shapes. None of them are flat though. Sorry, flat earthers. You guys are still wrong. There's a comet shaped like a bone and a cigar, and this one looks like a rubber ducky. That's a good one. So all of these wild shapes occur because they don't have enough gravity to turn into a sphere shape. But Pluto does. I mean, look at it. It's round. Pluto 2, haters 00. Speaking of haters, I read some of your comments the other day, and gotta say, some of you hurt my feelings. You think I'm AI? There's no artificial intelligence in this handsome space explorer. Everything you see is real. Go over to Patreon, see what I mean. Now, back to Pluto.
You are forgetting the 3rd criterion for planet qualification. A celestial body must have enough gravitational force to clear the area in its orbit. Pluto shares its orbit with small, icy bodies in the Kuiper Belt, so it cannot be classified as a planet.
Pluto's orbit crosses that of another planet. That's no kind of behavior for a planet. Pluto had it coming from the beginning. Just, get over it.
2 out of 3 ain't enough? Ugh, man, the Astronomical Union are such keeners. I mean, Pluto has enough mass and gravity to form it into a sphere, but not enough to impact the objects around it? Ugh, seems pretty arbitrary to me. So basically, it got kicked out of the Planetary Cool Kids Club for being too skinty? Ugh. Whoa! Whoa! Rico, you're supposed to warn me about these kind of things. Bad things tend to happen to me.
Acknowledged. Danger. Crater detected in front of you.
Are you serious? Yeah, I see the crater, Rico. Thanks. Damn! Look at this thing. It's huge.
Craters on Pluto range up to 260 kilometers in diameter.
Whoa. Isn't that like half the size of this boulder?
Pluto is 2,376.6 kilometers wide. That's 2/3 the diameter of the moon.
What? 2,400 kilometers? I mean, like, I could walk that in 4 days.
Inaccurate.
I mean, okay, maybe not walk, but if I ran, I could for sure do that in 4 days.
The average maximum run speed of a humanoid is 8 kilometers per hour. You are well below average human.
Okay, Rico, all right, enough of that. It's still a very small planet, though.
Still not a planet, but yes.
Right, so Pluto's giving dwarf planet, so we just need to figure out a way to bulk it up. Give it a little ass steroids, you know? Make it a heavyweight champ. Oh, I've got it. Pluto lives in the Kuiper Belt, the region of space just beyond Neptune's orbit, and that place has a ton of icy objects and asteroids. Some of these guys are pretty big. I mean, not big enough to be called planets, but maybe if we put them all together, we could make the biggest planet of all time.
Calculating the likelihood of creating the biggest planet of all time. 0.0005%.
Rico, buzzkill, okay? I was being hyperbolic.
I cannot compute tone.
Okay, well, not the biggest planet of all time, but bigger than it is today. Let's see, if you... Okay, so you gotta take that mass of the... Okay, actually, I don't want to do this math. Rico, calculate Pluto's mass if it absorbed every object in the Kuiper Belt.
New mass would be 6 times 10 to the power of 23 kilograms. New diameter would be 8,500 kilometers.
Yeah, okay. Well, that's super clear, but maybe also just for the people in the audience who didn't get that, could you explain it better?
Pluto would have a greater mass than Mercury, and almost as great a mass as Mars. It would be wider than many planets, including Mercury and Mars.
Yes, let's freaking go, baby! That would definitely make this a planet classification. Rico, let's make this happen.
Assessing risk. Disastrous consequences foreseen.
Once again, Rico, you insist on being a buzzkill, okay? We're trying to make a planet here. Who knows? Maybe it could even be habitable.
Extremely unlikely. Slow rotation suggests no magnetosphere. Location far outside the habitable zone of the sun. No hard evidence of an existing ocean.
Okay, yeah, okay, I see your point on this one. The heck? What is this? Get it? Who? Okay, someone needs to fire this editor. But still, we could deliver Pluto justice. Bring it back to the mainstream. Everyone deserves a second chance. Like Lindsay Lohan with those Netflix movies. She's killing it. So it's clear that Pluto is currently not a real planet. It's a dwarf planet. Sorry, I know this must be disappointing. But not to worry, I have a plan to make Pluto a true planet.
Disastrous consequences foreseen.
Okay. Disastrous this, disastrous that. What is it that you are so concerned about, Rico?
Pluto and Neptune cross orbits at 2 points. Currently, they are in orbital resonance, which means their orbits are locked in a repeating pattern, preventing them from ever getting too close and colliding. If one gravitational force changes, the planets risk collision, and absolute destruction of the solar system may ensue.
Well, that doesn't sound good at all. You know, I really thought we could find a redemption arc for this little guy, you know? I thought he was big enough. I thought he could go the distance, but I guess not all fallen heroes are meant to be redeemed.
Hazard detected.
Okay, well, finally we get to Pluto. Pluto is the smallest planet, or
Not even a planet anymore.
not a planet anymore.
Demoted.
It's now called a dwarf planet. It was a planet for a while, but then all those bigwigs in the Space Society got together and said, sorry, Pluto, no longer a planet. And I'll tell you why. There's criteria if you want to be a planet. There's three criteria, actually, if you want to be a planet. One is you have to orbit the sun. The sun is the center of all our solar system, and that's what determines what a planet is because it's orbiting your sun. The second criteria is you need to be spherical or nearly spherical, almost completely spherical. Pluto, I think, fits into that, but it's failing on the third criteria. And the third criteria is you have to have cleared your orbit. So it's almost like you have to shovel your driveway when it snows. You got to make sure that there's nothing that's going to stop you from completing your orbit. And now that's where Pluto fails, because there's still a lot of icy objects out there, because Pluto's close enough to the Kuiper Belt that a lot of icy objects from the Kuiper Belt are in Pluto's orbit surrounding it, which means it hasn't cleared its orbit. It's got to get rid of those things. Then maybe one day
It could upgrade.
back to normal, okay? So let's spend a day on Pluto.
Yeah, let's do it. So this is the big, beautiful planet right here. Before we dive into it, as you can see,
It's a dwarf planet, remember?
it is a dwarf planet. It's not. It was until a certain time.
Former planet.
So we're gonna jump to what it's like to be on Pluto
Okay.
during the sunrise.
So we're starting approximately, well, it doesn't really matter because time's not time on Pluto, is it? So
No.
we'll say this is 6 o'clock Earth time in the morning. And up comes, it's sunrise to sunset.
This is gonna be sunset, and then we're gonna see it. Actually, let's do. Oh, this is sunrise. So let's start from the very beginning. Complete darkness, and we're gonna have it go forward.
Now, I guess because on Pluto, a day is the same as, one day on Pluto is 6.4 Earth days.
Yeah.
So would that be 24 hours times 6.4?
Yes.
So the sunrise is not only going to take a long time,
It's gonna be up in the air for a very long
it's going to
time.
be up in the air
So,
for 6 days.
What we
Well,
can
not
see
quite.
here, which is really fun in the software, there's this thing called time scale, which is basically how fast we're making the universe go. So if I back it up a little bit here, if we do it at 10 times speed, so 10 seconds per 1 second, 30 seconds per 1 second for us, and as we keep increasing it, we only really start to notice movement at around, if we do 1,000 seconds per
There we go.
second,
Yeah,
and that's
finally.
where we can find.
That's 1,000 seconds.
1
per
second for us is 1,000 seconds going on this planet.
Because of my quick calculation, 6.4 times 24 hours, that means a day on Pluto is 153 hours.
It's a long time.
So if a sunrise here takes, 10 minutes, a sunrise there is going to take an hour.
Yeah, times that by 6.4.
It'd be fun though. Have
To,
a
like,
1 hour sunrise and a 1 hour sunset.
Wouldn't it be fun to have a 6.5 day though? It'd be a very long day.
Pretty fantastic. Now, the sun is shining on Pluto, but it's not warm.
No, it's
It's-
very cold.
It's 230 degrees below 0 Celsius
Yeah.
on Pluto, despite the fact that the sun is there. And that is because how many astronomical units away it is? 40 times. Is it 40 times further from the sun than Earth is?
Yeah.
So you could think 40 times less warmth, or actually probably goes exponentially. So it's probably more than 40 times less, obviously, because our temperature is, say 22 degrees Celsius, and this is minus 230 degrees Celsius. So
About a regular day in Canada. So.
yeah. It's actually the coldest surface in the solar system that you can stand on. And believe it or not, you would be the warmest thing on Pluto.
I can see that. And as we can see
Yeah.
the sun slowly coming through the air, now we're going at 30,000 seconds per second for us. So it's slowly making its way across. As we can see this beautiful Plutonian landscape, very rocky, lots of, we see a lot of things like collisions or different rocks that have hit it or joined it as the sun is.
Items from the Kuiper Belt, maybe while it was trying to clear its orbital path.
Exactly. And a fun fact, I didn't realize that Pluto has 5 moons.
5 moons
5 moons.
and not a planet.
It's 4 more than us.
Isn't that
It's
crazy?
not even a
You can
planet.
have moons and not be a planet.
Yep. No, Now let's see where that sun is. So we're gonna hit sun, and I'm gonna hit center. We're gonna see where it is in the sky. So it's directly above us. So another thing to note is that this isn't going to be a perfect one-to-one full over, kind of like the Earth, because of the way that it's very slightly off axis. The Pluto will have a little bit of a weirder, like the sun won't look like the same as it does on Earth. It'll kind of like twist.
Right, I noticed it was coming on it looked like on an angle.
And so here it is as it's coming down. A long day. You've had a long 6-day work week.
It looks like a fast sunset, but really you're going at...
Yeah, if I were to play it at, this is 3 times speed. It doesn't even look like anything's happening.
No.
And if we were to bump that up,
3,000 times.
yeah, this is 3,000 times that speed.
Wow.
It slowly gets in there, and we say goodnight for Pluto. Oh, it's
Now,
really-
it's so cold out there, but this is not snow on the surface, right?
No.
But the cold, it's not like windy. It's the cold is actually emanating out of
Pluto itself.
the rock Pluto. It's coming right out from the nitrogen ice beneath your feet, emanating right through the regolith, I guess. Is that what that is there?
Yeah.
And freezing you. But for one brief shining moment, you were the warmest thing on Pluto, and until that nitrogen ice cold comes out of the regolith and freezes you, presumably to death.
So Peter, what are you feeling on a scale of 1 to 10?
Well,
How are you feeling about jumping on and hanging out on Pluto?
there's bugger all there, realistically. Like, there's nothing going on Pluto. There's no, there's no atmosphere. There's no water. There's no trees. There's nothing to do. The one bonus it has going for it is the long sunsets, which I love a sunset. But like we're saying, we're 40 astronomical units away from the sun. The sunset is just this little tiny marble going down like this, and it's going much slower, but still, it's a little tiny little sunset. It's not really fun. And of course, it's not an orange sunset, as we noticed, right?
No.
And the reason why is, do you remember?
The atmosphere?
The atmosphere has no atmosphere, but what it does give off is nitrogen, and there's this blue haze there.
Yeah.
And the blue haze is sort of, obviously there's warm yellow red light coming off the sun, but the blue haze is splitting the color.
Yeah, this is that blue haze from afar. So there's Pluto, and then when we put it with the sun there, we can really see that blue.
Yeah, so the sun's light and color of the sun's light is shining on Pluto, but that gas is splitting like a prism, splitting the light and pushing the red aside, and you're seeing a blue sunset rather than a red-orange sunset.
So then what number would you give this?
Oh yeah. Back to what number I was going to give it. How about a 2?
I feel like 2 is completely fair. I'd almost go 1. At least you can stand on it. I think that gives it a little bit of a bonus compared to most of the other planets.
Did we talk about the gravity? You can stand on it, but it's 6% of Earth's gravity? Mm-hmm. So I'm in one big jump, and you're
almost gone.
And you're almost if you have the velocity to get out of get away from Pluto's mass, then you might find yourself floating in space for the rest of your short life.
You do one jump, and you just kind of
that's me jumping.
Keep going, and look at the sun as you do.
So that would be fun. So you got that. You got a different sunset. You've got the ability to take fun jumps. And what was the third thing that I was saying earlier?
That makes it nice?
Yeah, the long sunsets.
The long, beautiful.
The long, tiny sunsets.
Sunsets.
So I guess 2. And you said?
2.
2, okay. Let's keep it at 2.
Okay.
So have we come to the end of the solar system here?
This is it.
This is how we wrap things up?
This is our final. There is something fun I can show you really quick.
Can we throw up a graph of how we rated all the planets along the way?
Yeah, let's throw it up here right now. here's a fun little. This is the TRAPPIST system's solar sunset. A lot better than Pluto.
Okay, TRAPPIST.
This is just a fun little extra. No information. I just thought it looks cool.
It's beautiful. Those.
This is very Earth-like.
It looks exactly like Earth, even with the
check out
Northern Lights.
the What If episode on TRAPPIST one.
Yeah, TRAPPIST 1, we did an episode not so long ago, and well, I'm not going to give it away.
39 light years from Earth, a tiny red dwarf star, TRAPPIST-1, sends its dim light to not one, but 7 Earth-sized worlds. All 7 exoplanets in the TRAPPIST system are jammed into space smaller than the distance between Mercury and our Sun. And at least 3 of these rocks are in the habitable zone, meaning we could live there someday. So we're sending our brave explorer Chase to the TRAPPIST system to rate all 7 planets from most habitable to most deadly.
No! You have poor balance, Rico. Totally deadly. Hey, Chasehead. So, I arrived at the TRAPPIST system, doing a little rate my exoplanets type thing for the What If gang, and I figured, TRAPPIST system, time to polish off those trap beats, right? Lay down some tracks for that hip-hop EP we've been talking about.
You've not mentioned a hip-hop EP.
Rico, what are you talking about? The Chase Trappistry? I've been talking about this for months. All right, well, I've been thinking about it for months. I probably haven't said anything. Anyways, check it out. That's all I got so far.
Oh, for a whole album?
I mean, it's a start. You try producing something, Peter. You know, a voyage of 1,000 miles starts with 12 fat beats, or whatever they say. Anyway, let's get Trappisting. Trapping? Trapeziing. Peter, Rico, where are we at?
You are currently in orbit around TRAPPIST-1b.
Okay. Why didn't we start with 1A?
There is no TRAPPIST-1a.
I'm pretty sure there's gonna be a 1A, okay? There's 7 exoplanets, A, B, C, D, E, F, G.
Well, you're half right. Or at least you know the alphabet. There is no TRAPPIST-1a. There's just TRAPPIST-1. That's the sun at the heart of the TRAPPIST system. It's an incredibly small, ultra-cool red dwarf star, about 10 times smaller and less massive than our sun. And it's 2,000 times dimmer. This star is the most common type of star in the universe, and it's barely bigger than Jupiter.
Aw, cool little guy.
It is cool. TRAPPIST-1 is only half as hot as our sun. It's also much older. Our sun is 4.5 billion years old, but this star, it's 7.5 billion years old. But don't let its size fool you. This star is dangerous. Red dwarfs regularly blast their planets with high-energy radiation and X-rays. TRAPPIST-1's flares could blow away a planet's atmosphere or anything living on them.
Okay, well, if there's no 1A, then Rico, I guess, take us down for a tour of 1B. Hey, where was it? Wasn't it here 1 second ago?
It was, but it went further into its orbit. All TRAPPIST exoplanets are in tight, fast-moving orbits around the star. The TRAPPIST-1b makes a full orbit in just 1.5 days.
Right, so when people ask you, how's your day? And you're like, it was a year, man! You are actually kind of pretty close. Kind of like the anti-Venus. remember anybody mentioning a volcano on TRAPPIST-1b. Is this, like, safe, Rico?
Define safe.
Do you really need me to define that for you? Is it like a cool vacation spot where I can get a margarita by the pool? Or is it a fiery hell planet where I'm gonna die by being volcanoed?
You have landed on the day side, away from active volcanoes. Roasting is unlikely.
Okay, well, it's getting pretty toasty over here already, even without any of that lava stuff. So...
Yeah, you're right. TRAPPIST-1b is scorching hot. Its host star might be cool, but this planet orbits 90 times closer to it than Earth orbits the Sun. At that distance, even an ultra-cool dwarf like TRAPPIST-1 heats the surface of this exoplanet to 225 degrees Celsius. That's 450 Fahrenheit.
Oh, hey, I know that temperature. That's frozen pizza temperature. You know, 450 degrees, what you set your oven to cook a frozen pizza. Oh, man. Does this planet have like a Terminator Zone, somewhere I can go to cool off, maybe?
Yeah, TRAPPIST-1b does have a Terminator Zone. All the TRAPPIST exoplanets are tidally locked to their star. They all have a day side, a night side, and an in-between Terminator Zone. But TRAPPIST-1b is still pretty big.
Oh, God. Man, it's getting hot. Like, how big?
It's almost the same size as Earth, and that means the Terminator Zone could be thousands of kilometers from where you are.
Oh, God, okay. I'll never make it in this pizza oven. Quick, Marty, we've got to go back to the ship. Oh, that's enough of 1B for me.
Warning. The heat is overwhelming your suit's environmental controls.
No, I won't make it. Oh, God. Oh, I got dizzy. I got dizzy because I ran hard. Oh. Where's the ship? Where's the ship now? What? I thought there was no lava here. Can you go that way? Yeah. Uh-oh. Oh!
Tidal heating from the star's gravity generates ongoing geological activity.
This is your fault, Rico.
Warning. Suit integrity compromised.
A, B, C, TRAPPIST, 1C, coming up on me. Rico, drop the B. Rico. Okay, Chaseheads, time to rank these babies. I got my hands on this super new, super exclusive software that was just released. Tier list. Okay, here we go. TRAPPIST-1b gets an F for habitability. All right. No, oops, I put that on S. Okay, there is no F. Okay, so I guess I'll put it on A. No, B. B is gonna be the worst planets in the universe, like someplace that I'd send Peter to, all right? Get on board. What's TRAPPIST-1c gonna be like? You know, I'm hoping for less pizza oven and more like pizza. All right, chat, let's check it out.
TRAPPIST-1c is on the heavier side. It's 1.3 times more massive than Earth, so the gravity here is slightly stronger than on Earth.
Still looks pretty pizza oven out here. Rico, what's the temp?
Temperature reading, approximately 107.31 degrees Celsius.
I thought TRAPPIST-1c was a little bit more Venus-y, you know? This is like, more deserty. Ugh.
That's what scientists first thought when they discovered TRAPPIST-1c, but it turns out this planet doesn't have a thick carbon dioxide atmosphere like Venus. The air here is pretty thin.
Whoa, check out all the other exoplanets. You can see, that's crazy. From Earth, you can barely see Venus. It's like a dot or something. Here, you can see everything, like craters and pockmarks and everything. So cool. Oh. Yeah, that was probably ambitious. Hey, what's, is this a volcanic activity?
It is. Like TRAPPIST-1b, 1c is so close to the star that it's got a lot of tidal heating. The landscape here is pretty unstable.
I don't see many volcanoes. Maybe that's one over there, but okay, it's a little windy up here.
That might be the remnants of the atmosphere. You're near the Terminator Zone, so the extreme difference in temperature between the day side and the night side is going to occasionally create hurricane-level bursts of wind.
Okay, Chaseronies, that stung. I just got killed by some wind. Ugh. But at least I didn't get cooked, so I'd rate this planet a D. But again, there's no D section. Software is so limited. Anyways, so I guess I'll place it at a B? Or maybe A? Maybe A. No, I don't think I'll ever come back here, so that goes to B. But I just want you guys to know that in my heart of hearts, it's still a D. Total dump.
Okay, I think you'll like this next exoplanet better. It's not as hot, and it's at the edge of the system's habitable zone, so that means liquid water. Maybe.
Whoa, feels bouncy in here, huh? Kinda light. Loving this low grab. Okay, cool. Hey, let's find some H2O. Oh yeah.
TRAPPIST-1d is one of the smallest exoplanets in this system. Yeah, because this planet isn't too massive, gravity here is only about half of what you'd experience on Earth.
I don't see any water around here. Just like rocks. Rocks. Oh, nope, that's just a rock. Oh, that's, could be frost, maybe? Some frozen water, huh? Some froyo H2O? Okay. At least it's not like hot here, you know? No crazy winds or anything.
Warning. Solar flare detected.
What? Okay, I guess, back to the ship? Rico, how long before this, radiation hits me?
You have 9.6 seconds until the radiation shower.
Oh, 9.6 seconds, that's not so bad. I can make it in time.
Starting 7 seconds ago.
Rico, why would you give me that stat 7 seconds late? Oh, I can make it.
Warning. Suit malfunction detected.
Oh, man. Oh, I hate when this happens. Oh, come on, Rico. Yeah, reboot or something. Oh, God. Oh, no. Oh, God. Come on. Oh, God. I just need some of that sweet oxygen, baby. Give me that O2. Okay, I gotta go for the manual release. Okay, Chaseheads, a solar flare, that can happen to anybody, okay? Still, I'm giving 1D an F on the Chase Survivability Tier List. Right, again, there's no F, so I guess it's a B? I don't know. You know, if it wasn't so hot and you built yourself like a radiation shielding bunker, you might be fine. I mean, maybe I'll bump it up to an A. Yeah, you gotta have some variety in here, right, chat? Right?
The next exoplanet is still in the habitable zone around TRAPPIST-1, so there's a chance it could land in your S tier.
Okay. Ooh, that looks very earthy. I dig it. Which trapper is this one?
This is TRAPPIST-1e. It's our best candidate for Earth 2.0. It's right in the middle of the habitable zone. It has an atmosphere, clouds, rain, land, lakes, oceans, even a similar surface gravity. The biggest difference is that it only takes 6 days to orbit its star.
Hey, Chaseheads, check out this place, right? Look, I get to set foot on a lot of new places, but you know, after a while, getting your footprint down on a planet is like so Apollo missions, you know? If TRAPPIST-1e is ever settled, I want to be saying, like, that I did something special, you know? I want to say I put on the first concert, something that means something to people. Yo, Rico, can I take my helmet off?
Negative. The atmosphere may contain unknown toxins or biological hazards.
Of course, whatever, man. All right, well, let's keep on surviving, learning, getting faster, stronger. You know, if Daft Punk can rock the helmet, I think Chase can. Let's do it. All right. I mean, I gotta dip the toe. Oh, I should have brought the surfboard.
You did bring your surfboard. It's literally all you brought, besides your drum machine.
Right, well, nothing lethal here, right? How about a little Beach Boys set? Maybe I can get my Hawaiian shirt on? Man, look at this place. Water, land, beach. Ugh. This could be the future of humanity. Earth 2.0. Baby, Rico, let's drop the beat. Where my TRAPPIST-1e ats? 1Ian's at? Who wants to hear some noise? Okay, chat, so technically TRAPPIST-1e is at the top of the most habitable list because liquid water and temperature, whatever. But we're still in space, and space is dangerous. So many ways to die. Solar flares, plasma, superheated winds.
Electrocuting yourself with a power cord.
Exactly, you know, electrical current malfunctions. Happen to anyone. Anyhow, TRAPPIST-1e is definitely S tier, chat. Here, you got it, okay? Boom, you can finish the video right here. 1e is the winner. Unless, you know, this F planet has something better. Ooh, unknown. And the unknown is a mystery. Gotta investigate that mystery. Sounds like a natural F, though. F, you know what I mean? God, I wish this tier list had an F on it. Is this really habitable? I mean, where's the liquid water? I don't know. Looks pretty snow-coney to me.
Well, there's a good chance it's habitable. TRAPPIST-1F is colder for sure, but it's still a water-rich world. Most of the water is just locked under a layer of another type of very special water called ice.
Ice is actually just uncooked water. Fun fact.
Okay. Look, TRAPPIST-1F receives about as much energy as Mars. So imagine Mars with a lot more water. Or Triton. It's possible TRAPPIST-1F even has cryovolcanoes.
Ooh, I love me a cryovolcano. Rico, let's land. The ship that we're flying. Now, Rico, start it. Okay, this isn't bad. It's like, I don't know, Antarctica out here? Not even, it's like Saskatchewan Christmas, huh?
It's closer to Antarctica. The jury is still out on the exact temperature, as scientists are still studying how much atmosphere exists on TRAPPIST-1F. If there's none, it could dip down to minus 59 degrees Celsius, minus 74 Fahrenheit.
There must be some kind of atmosphere here. I mean, like, this place is kind of slushy. You know, maybe some cryomagma? Whoa! 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 Yep, as I suspected, TRAPPIST-1F is definitely an F planet, chat. But again, nobody put an F on this list, so I guess it's like a B then? Ugh, this just seems so unfair to all those other B planets, you know? Because F is really so much lower on the list than B. Okay, 2 more planets to go. Yup! I bet this one's an F planet. It doesn't get better from here. It never does.
It's hard to tell from the orbit because TRAPPIST-1G has a dense atmosphere. All we know is that it's the largest of the TRAPPIST exoplanets, a so-called super-Earth. And it's located right on the edge of the habitable zone. We'll find out when you get down to the surface.
Rico, my good man, to the surface, post-haste! Okay, Rico, less post, less haste. Go. Oh, my martini. Whoa, full-on water world. Is there any place to land? You know, any land to land upon?
Negative.
Fascinating. TRAPPIST-1G appears to be a purely oceanic world. a deep ocean over a rocky core and a thick atmosphere. It looks like what scientists call a Haitian planet.
A what planet?
A Haitian planet basically means hydrogen and ocean, a high-shen world. It's an exoplanet with humongous oceans and a hydrogen-rich atmosphere. The thick atmosphere keeps the planet warm enough for this much water to exist.
Oh, Haitian. Geez, sounds like I kind of named it, right?
Haitian worlds are a pretty recent discovery. Scientists are beginning to study and search for this class of planet. You know, a planet this big with this much water and energy, well, could have life.
Super Earths lead to super whales and super waves. Man, forget those 100-foot waves. Look at some of those rollers. Oh my god. What? Rico, are you thinking what I'm thinking?
Negative.
It's surfing time, Rico. I mean, why do you have to be such a disappointment, man? Rico, how big is this wave?
Calculating. Which wave are you referring to?
The one I'm frickin' carving up right now, Rico!
You're not on a wave. Water movement is negligible. Your movement is due to your poor balance.
You have poor balance, Rico. Oh! Oh god, why didn't I ever finish those swimming classes at the Y? God, why is this so hard? No. Okay, Chaseheads, I know TRAPPIST-1G isn't, like, habitable, but for the craziest, like, double-up rogue tsunami wave that I've ever seen in my life, maybe you guys didn't see it, I think we might have, like, lost some of the footage or something. Whatever. Anyways, it gets an A tier for me. There you go. Haitian planets, rock! Yeah! Not rock enough for S tier, but A isn't too bad.
Okay, you've got one more exoplanet left to rate. TRAPPIST-1H, the outermost planet in the TRAPPIST system. And it's just out your starboard window.
They're all starboard out here. Oh, there it is! The big H. Or little h, like lowercase h. It's actually kind of cute. All right, let's check it out, Rico. Did you hear me?
We still don't know much about TRAPPIST-1H. We know that it's the smallest of the exoplanets, approximately 1/3 the mass of Earth, and it's outside the habitable zone. At that size and distance, it's unlikely to have much atmosphere, so it's a tiny, frigid ice ball.
Oof, it's, chilly and quiet. A little too quiet.
Temperature reading, minus 100 degrees Celsius.
TRAPPIST-1H is a place of endless night, micrometeors, and crevasses. Perfect quiet, perfect doom.
Whoa, jeez, existential much? Ugh. Oh, no, I think it's kind of pretty out here, you know? And I'm still buzzing after that sick, gnarly wave I did. So, I think I want to just, sit down, look up at the exoplanets, little sun. It's kind of got charm. Peter, did you say micrometeorites?
I did?
Yeah. Well, I thought so. Oh, man.
Hey, chat. What an epic way to go. You know, I really like this planet. Let's move TRAPPIST-1H to S tier. Now, TRAPPIST exoplanets aren't the only promising worlds out there for humans to look for life or even a future home. How about sending Chase to surf or live or possibly die on Proxima Centauri b? Well, that's a story for another What If. Mercury is a strange, hot mess of a planet. This rock is the closest one to the sun, but its surface temperatures can plummet to as low as minus 180 degrees Celsius. It has the strangest sunrises and sunsets in the entire solar system, and one day on this planet lasts about 2 years. But you don't have to survive a whole day down there. We're sending our team member Chase on a mission to spend just 5 seconds on Mercury.
Huh. Mercury doesn't sound so bad. I just don't get why it's so cold. It should be flaming hot.
Detecting extreme temperature fluctuations.
Yeah, Mercury is hot and cold at the same time. That's because instead of a proper atmosphere, Mercury has an exosphere. And this exosphere is almost as thin as the vacuum of space. It doesn't contain enough molecules to transfer heat around the planet, and that means surface temperatures go from one extreme to the other. During the day, the surface is blasted by intense sunlight, and that results in severe heat, like 430 degrees Celsius. Then at night, all that heat gets lost in space and the temperatures drop to minus 180 degrees Celsius.
Well, at least there's no dust storms on Mercury.
Sure, there's no weather and no climate on this planet, but there are plenty of things that can kill you. Extreme heat,